Hello and welcome, Bob Marley. Welcome, Daddy Crew. Thank you so much for passing by, and thank you for the lurk. And yeah, enjoy your gaming session. And shout out to you if you want, again, another fitness streamer, fitness workout streamer, and also playing games, racing, and also in real life driving streams. Definitely check out Daddy Crew. And yeah, as usual, I'm Corey Campbell. And well, I'm back. I am trying to stick to the schedule that I posted in my Discord. Really trying to aim for, yeah, bare minimum three streams per week. And I think looks like I'm gonna hit that benchmark this week. But I don't want to jinx anything. I plan to be back tomorrow, and I'm probably not gonna be able to cover everything that I want to today. I'll just cover it tomorrow, and there's always, again, an ever-increasing amount of content that I want to get to. And there's I think some really super interesting stuff that I want to get into, and that I'm trying to prepare for. I still have this has been in the works for a while, but this is I'm really trying to do my due diligence and make sure that I do it the way that I want it to be done, even though it's not like an actual serious science stream, but going over pretty much my argument. And presenting the evidence as to why I think cats are better than dogs, and that there's research. I'm going to try to present that research to back that up, even though I love both. I'm just more of a cat person. And yeah, I've been trying to stream consistently again, and so far it's working out. It really is all dependent on my sleep and my sleep quality. If I can get a decent amount of sleep, then really not a problem for me to stay consistent. I'm still going to the gym. The consistency, I'm usually pretty good with consistency. If in fact it's something that I want to invest in, as in if I'm actually invested and I have the resources and the time, and it's something that I actually value, then I can be pretty consistent. It's just a matter of whether I can incorporate it into my life the way that I want. Where it's I think consistency is one of my strengths. It's just a matter of where I actually channel it. And maybe that holds true for probably everybody. But I'm really consistent when it comes to the gym. Where I'm pretty much going in and day out. And I pretty much, I think throughout the year, if you tally it up, I think I'm I have a 95 or 98% consistency rate when going to the gym. But then these days, like I said, since it's dependent on sleep, if I drag myself to the gym and I didn't get the greatest sleep, then I don't have much energy afterwards, after a gym session. So now that the sleep seems to be on track, or much better than it was a month ago, now I can actually go to the gym and I have energy to do stuff for the rest of the day. Even though my gym sessions don't drain me typically, but yeah, if I got 3 or 4 hours of sleep, and then I pretty much channel whatever energy that I have into the gym, there's nothing left over. But now that I'm getting pretty good sleep, I have energy left over after the gym. And absolutely, cats are objectively better. I'm gonna try and make that case. I've accumulated so many articles, both mainstream and scientific studies, make that objective case that cats are better. Oh, you got a home gym. So did you invest in resistance bands, kettlebells, dumbbells, all of the above, barbell? And I hope that... One second. I assume you're probably going to get your test results back soon. I hope everything... at the end of the day, I hope you get answers that are helpful to you. I think that's what matters the most. And yeah, like I've been mentioning, trying to resurrect the workout and gym stream, and I'm optimistic about that, that it's going to happen sooner rather than later. Like I said, I think in the next 6 to 8 weeks, I can have the gym streams and gyms and workout streams back. But that's not a promise. And also, I feel like I probably owe an apology for last stream a couple days ago, where I totally lost track of chat which I don't think that's happened before. I think there was like a good like 30 minutes to 45 minutes where that's like, yeah, I just had the chat not scrolling properly, which, whatever, mistakes happen. But that, yeah, totally dropped the ball there. Maybe a reflection of my poor sleep quality and cognitive decline, as I said. Yeah, I think we're just going to dive right into it because actually I have quite a bit that I want to try to get into, at least as usual, try to cover the main topics. So, a whole rack and preacher curl. Wow. Well, that's fantastic. As in you have like pretty much like a whole squat rack with like a barbell. That's awesome. That's pretty much like the dream for me. Or like close to there. Like definitely if or when I get a home gym. I definitely plan to have a whole squat rack. And also, you know, bench press setup, etc., etc. So I'm definitely covering some AI stuff, or kind of like recovering some AI stuff. It's more like a follow-up of research that I've covered before in terms of, you know, I covered, well, I guess I'll save it when the time comes. But just to kind of like dive into the AI stuff, this article came across my newsfeed, which I thought was pretty interesting, and opens up a whole host, I think, of both positive and negative implications of like I can totally see value and utility for AI being someone's best friend or AI being someone's, you know, only semblance of connection to a quote-unquote person. But then at the same time, if it becomes like a total substitute, and that's the only type of interaction that a person has, or like a young person, such as a teenager, then I'm not so sure about that. Or I definitely have potential questions and concerns. Squat rack, adjustable bench, Olympic barbell, pretty, yeah. Now you have no excuses. And I'm actually kind of excited for you. Because I know that you're not a fan of the squat. You're like a leg press, hack squat type of person. Just totally fine. No judgment on my part. And actually, maybe I can provide some reassurance to you. Not that I would want to discourage squatting. There's research that I came across that I'll probably cover on a future stream if I can get access to the whole article. But it's basically, oh yeah, this is published like a little over a week ago, August 2nd, where it's pretty much, it's a comparison between, you know, free weights and machine-based training, at least when it comes to, you know, strength and hypertrophy. And well, there doesn't seem to be, at least from this study, but I haven't really haven't been able to take a closer look at it because I don't have access to the full study, but I'm going to try and get it. But basically, yeah, there doesn't seem to be a huge difference between free weight versus machine-based modalities. Are similarly effective to promote strength and hypertrophy without increasing joint discomfort. You know, again, not that I don't think this is like a, you know, case closed, that, you know, you can just avoid free weights and there's no detrimental effects whatsoever. This is one study. Obviously, I've only read the abstract because that's all that I have access to. But it's also like, it's not surprising, but it's good to know that, like, yeah, totally, you know, no surprise. You can build strength and induce hypertrophy with machines, and you don't absolutely need free weights. But this is, you know, not exactly a huge sample size, and it's only men, although, you know, that's applicable to you, Bob Marley, presumably, and it's a fairly short time, 8 weeks, but still, you know, some evidence is better than no evidence, obviously. So yeah, that's pretty cool, but I still think you should squat, okay? And this doesn't say anything about mobility and flexibility, okay? Which are important components of, you know, health and fitness, especially as you age. Yeah, I think it's more and more becoming apparent. that mobility and flexibility is a pretty critical component of health and fitness that you want to preserve or maintain as you get older. And I think that's an often overlooked component. Obviously, I enjoy, strength training and all that stuff. But I think if you're too focused on that, like, I don't think it's conducive to the greatest quality of life when it comes to longevity. Or at least I think there's definitely other things that, you should also cultivate. But that's just my personal opinion. But yeah, gonna put this on the back burner. And again, gonna try to get access to the whole article. Actually, maybe before covering this, I guess since we're on the theme of health and fitness, and this is a short article, so it's not gonna take that much time. But this is basically on supplementation. And let's say, trying to assess the quality of supplementation or supplements that are on the market that, I would say not really all that regulated or not regulated well. And I think this research here kind of highlights that. And, I would say is a good argument as to why there should be more regulation or much greater scrutiny on the supplement industry, because this, the percentage of, let's say, contamination or poor quality seems to be pretty high. The only problem is that the ceiling isn't that high. So to get the barbell on my shoulders, I have to crouch down a tiny bit. Yeah, that's fair. Or, a few dents in your ceiling, for the sake of strength gains and squatting might be worth it. But I know it's, it's probably not your home. But still. Okay. So since the U.S. Food and Drug Administration banned ephedra from dietary supplements in 2004, supplement manufacturers have promoted a complex variety of alternative botanical compounds for sports enhancement. And I think this fits in nicely with sort of what I covered last stream about, a bodybuilding supplement known to have maybe some cognitive benefits, at least in mice, yet to be determined in humans. And it's a supplement that I happen to take and I've been taking for a while. And, just about every supplement that I have come across on the market, they always say oh, it's tested, this is actually what's inside, quality guaranteed. I never really put much stock into those labels. Or good manufacturing practices, etc., etc. Basically, unless I'm the one that's going to do the testing, or I get one of my colleagues, I bring it to the lab, and they're going to do the testing, I see the results, I'm pretty much not going to trust labeling all that much. But yeah, extracts of Rauwolfia vomitoria, containing alpha-yohimbine, the caffeine-like compound methylliberine, the partial beta-2 agonist halostashine, the plant steroid turkesterone, which, this appears to be making the rounds or has become quite popular in the past couple years. And norepinephrine, octapamine, are all found in plants and are promoted in dietary supplements for their stimulant or anabolic effects. The FDA does not pre-approve these ingredients or any supplement ingredient for either efficacy or safety before their introduction, but FDA inspections have found that supplement manufacturers often fail to comply with basic manufacturing standards, such as establishing the identity, purity, or composition of the final product. Given the product's potentially complex physiologic effects and concerns regarding manufacturing quality, we determined the accuracy of dietary supplement labels declaring R. vomitoria, blah blah blah, and turkesterone. So, they're pretty much trying to assess the quality. Or the accuracy of, does the label or what they're putting on the label actually match what is supposed to be in the bottle. If I really wanted to, yes, I could. I definitely have connections with people that do testing in that vein. Although most of them are in actually in the testing in basically performance-enhancing drug testing. I actually know someone, or I have a connection with someone who essentially works for WADA, for like the World Anti-Doping Agency, and like, you know, does that type of testing. And I also know some other, I have connections with some other forensic chemists where, like, if I really wanted to, you know, I'd probably have to like jump through some hoops, or, you know, kind of like do it under the radar. But if I really wanted to, I could. And I can maybe do some of it myself. It's mostly just the access to the equipment that is the barrier, as in, since I'm a biochemist, like, we don't work with that type of, we don't typically work with the type of equipment that's required to do that type of testing. Methods, well, not super critical, but even though, well, it's short, so might as well go through it. Dietary supplement products were included in this case series if they were labeled as containing one of the following ingredients, which is like, yeah, the R vomitoria, methylliberine, turkesterone, halostashine, or octopamine, which I actually haven't heard of any of these except for turkesterone. All products were purchased online, which I think is pretty typical. I definitely purchase supplements online regularly. Products were excluded if the actual label did not list one of the 5 ingredients. So it's like, yeah, you know, it has to, well, yeah, the labeling has to match what they're looking for. Powder from the dietary supplement products was reconstituted in methanol and analyzed for the presence and quantity of the 5 ingredients. And they also looked for FDA prohibited ingredients by liquid chromatography, quadruple time of flight, mass spectrometry, which is like, yeah, I know these techniques. And, you know, I have sort of done mass spectrometry, but I'm definitely very far from an expert. And just, you know, very casual user. And if anything, I arguably didn't carry out the full techniques. I just mostly did the sample preparation, and then I handed it off to the person who actually knows how to operate the instrument. So, results. Of the 63 products purchased, 6 did not list one of the 5 ingredients on the label. Therefore, 57 products were analyzed. They excluded, you know, basically, arguably misleading labeling. So 23 of 57 products, so 40%, did not contain a detectable amount of the labeled ingredient. Of the products that contain detectable amounts of the listed ingredient, the actual quantity ranged from 0.02% to 334% of the labeled quantity. So like this huge range. You know, you're either getting like, well, for some of them, you're getting like nothing. And then for other ones, you're getting like trace amounts or like, you know, crazy dosages. So basically, seems just like a roll of the dice. You're either, you know, you're getting nothing, trace amounts, or like a whole lot. Which I guess, you know, if you're getting a whole lot, I guess you're getting more than you paid for, but also at the same time, you might be potentially overdosing or consuming too much of a substance unintentionally. 6 of 57 products contained a quantity of the ingredient within 10% of the labeled quantity. I read another crazy thing like that the other day where a lab tested vegan food and I think found, and that doesn't surprise me at all. Like, yeah, our food and supplement practices, pretty shady. So 7 of 57 products were found to contain at least one FDA prohibited ingredient, so over 10%. Containing an FDA prohibited ingredient. 5 different FDA prohibited compounds were found, including 4 synthetic, it probably means stimulants here as opposed to simulants. 1,4-dimethylamine, deuteranol, octodrine, oxylifrene, umburacetam. I only know 1,4-dimethylamine. Haven't heard of the other ones. 6 products contained one of these prohibited ingredients, and 1 product contained 4 different prohibited ingredients. Again, looking pretty bad. So it's, yeah, not only are you potentially like not getting anything at all of what's supposed to be in the bottle, but you also might be getting some, well, prohibited ingredient that, like, I don't know them, so I can't speak about them. But I'm assuming they're, prohibited for a reason, although it may not be the case. Sometimes things are prohibited for silly reasons. But either way, that should obviously be on the label. Or rather, obviously not sold if it's prohibited. So 89% of dietary supplements, supplement labels do not accurately declare the ingredients found in the products. And 12% of products contain FDA-prohibited ingredients. A prior study of dietary supplements before the FDA ephedra ban found that 6 of 12 products contained ephedra within 10% of the labeled amount. In a more recent study of caffeine content of sports supplements, 9 of 20 products contained a quantity of caffeine within 10% of the labeled quantity. In the current study, which to our knowledge is the first to quantify these 5 supplement ingredients, only 11% of products were accurately labeled, and 5 different FDA-prohibited ingredients were found, including an unapproved drug available in Russia, which is this amber-acetam, and 3 drugs formerly available in Europe, and 1 drug that has never been approved in any country. Yeah, the one for dimethylamylamine. Let's see. You probably don't give brands. Like, yeah. These are the types of claims that they're making on the label. They pretty much, yeah, from fat burner, pre-workout, energy, or aggression. I don't like, yeah, weight loss. Oh, thank you. From the, hopefully I can access it. Sometimes I get, like, restricted from the independent. Okay, so, where was I? Yeah, the study has limitations, including that the sample size was small, only 1 sample of each brand was analyzed, and only supplements containing 1 of 5 targeted ingredients were analyzed. Right. They didn't obviously, they didn't test creatine, or, like, I guess the popular ones, like creatine, maybe, like, some branched-chain amino acids, or, well, caffeine, or, like, caffeine content or pre-workout, although they sort of, like, talk about it, in the discussion. It is not known whether the results are generalizable to other botanical ingredients in sports supplements, or whether quantities might also vary among batches within a given brand. Given these findings, clinicians should advise consumers that supplements listing botanical ingredients with purported stimulant or anabolic effects may not be accurately labeled and may contain FDA-prohibited drugs. And let's see. Conflict of interest. Consumers Union. Nothing that really stands out as a major conflict of interest. I mean, regardless, even if there is a conflict of interest, doesn't nullify findings of this study. But yeah, something to be aware of. This is one study, only looking at 5 supplements. But even then, doesn't look good. And I would say that, they're looking at supplements, I think, more on the extreme end of, like, this testosterone. I think many people take it with the intention, or thinking that'll, like, boost their testosterone, or, increase, well, yeah, they claim to be a plant steroid, and it's thought that whatever, it'll act as a steroid, an anabolic steroid, if you take it. Obviously not as potent as actual human testosterone, but I think that's sort of like how it's marketed as. Of like, oh yeah, it's a plant steroid that might have some anabolic properties. And yeah, these other ones basically seem like yeah, more on the extreme end of the supplementation. I've never taken any of these, and have no intention of taking any of these. Unless, like, they're actually shown to be safe. You're probably not wrong. In terms of, like, yeah, the fact that it just sounds like testosterone. So, a third of vegan products contain milk, egg, or egg. Shock findings show. Which, yeah, totally not good for, people that want to be strict vegans. A little bit less of an issue for me, since, I'm technically not vegan. I'm a vegetarian. I consume a little bit of dairy. I consume a little bit. Well, I buy and consume whey protein derived from dairy. I don't go out of my way. I don't buy eggs. I don't make eggs myself. But if there's something that contains eggs, I'm not staunchly against eating it. And I don't drink cow's milk. And I don't, yeah. Like, the milk that I buy is currently oat milk. So more than a third of foods labeled vegan have been found to contain animal products, leaving shoppers with allergies potentially facing tragic consequences. Yeah, that's another aspect to consider. This is maybe a potentially, life-threatening situation. Inspectors from Hampshire and Kent Scientific Services found that 39% of dairy and meat alternative products contain egg or dairy. They found 90% of the products marked as vegan to be unsatisfactory as they failed their tests for traces of dairy or had inaccuracies in their labeling. They included vegan alternatives for chocolate truffles, pizzas, burgers, muffins, and wraps. According to a recent poll by the Chartered Trading Standards Institute, 76% of 2,000 people believe products advertising themselves as vegan were free from animal products. Which is like, yeah, that's how it should be. John Harriman, the chief executive of the CTSI, told The Guardian that the ambiguity from the lack of legal definition of vegan could be exploited by food businesses. Sure. But this doesn't seem like, it seems like it was more like a consumer study. Is there any scientific reason behind you buying whey protein rather than... not really, no. Even though, like, it's kind of... might have slightly greater bioavailability, but I only really buy it for, generally speaking, cost saving, and it doesn't, my digestive system, which is, fairly special to say the least, can handle it. Like, I do consume a vegan protein, but I consume it, I can't really consume it like every day or in large quantities because I just go through it so quickly. And the vegan proteins tend to be like way more expensive. I can buy, like I literally just bought, I think it was like 7 kilograms of whey protein for like $2.50 Canadian. If I were to buy that equivalent amount in vegan protein, it would be like 50% greater in price, or like almost double the price. It is largely like a cost saving, and that at some point, when cost is less of an issue for me, or the prices of vegan protein powders come down, then I will gladly buy them. Like slowly, I am like inching towards being fully vegan. Oh, and Doffy, welcome. Thank you so much for passing by. Nice to see you. I hope you're doing well. Where, when I first started as a vegetarian, and I started, as a vegetarian, I technically still am, but I've totally have, like, made some changes. Where it's like, yeah, I would actually buy eggs when I first started, and I would actually, like, buy milk for cereal. I no longer do that, and I haven't for quite a while. And I would also, like, buy cheese, and add cheese to, like, dishes. I don't really do that anymore. At most, I make, like, one actual dish that contains cheese, which is a pasta dish. Well, it's fettuccine alfredo, which contains Parmesan cheese, and obviously cream. But that's pretty much, like, the extent of it. Basically, like, when it comes to my grocery shopping habits, I would say I buy pretty much all vegan, or like 98% vegan, and mostly I'm I'm like a vegetarian when I'm like out in the world, socializing with friends at a restaurant or at a family gathering. I absolutely will not consume animal flesh. That is more or less like my baseline, fundamental baseline. Yeah, Alfredo. Well, I try not to justify it. I'm sure there's like an appropriate fettuccine Alfredo vegan substitute out there. I just have to like put in the effort to like find a recipe, try it out, and tweak it, and to get it to my liking. But since there's obviously way more, conventional fettuccine Alfredo recipes, uh, like yeah, it's a matter of convenience, unfortunately, for that particular dish. Where was I? Yeah. He said, perhaps of greater concern is that this ambiguity can have disastrous and sometimes tragic consequences for those with allergies to animal-derived products like milk and eggs. Absolutely. And even just going back to this research here, it's unlikely since these are pretty niche substances, but like, it is totally possible that, one of these prohibited substances that are found in these supplements, someone might have an allergy to, or like it's totally possible, maybe unlikely, but possible that, it conflicts or interacts with a medication that they're taking. And so, like, if it's not on the label, or that they're not knowing that they're taking it, or, it might have some other, effects that they just don't know about. So, yeah, a whole host of potential negative consequences. We are aware that people have sadly lost their lives because of this, and are therefore calling for more clarity on what can and can't legally be described as vegan and plant-based food. And it's my understanding, at least based off, sort of what I observe and what comes across my newsfeed, and maybe you can shed some light, Bob Marley, since, you're obviously UK-based. But from what I understand, like, there are way more vegan options in the UK, way more like vegan restaurants, and more options when it comes to the grocery store or supermarket. At least that's sort of the impression that I get from the vegan content that I consume. In 2017, Celia Marsh, 42, who had an acute dairy allergy, ate a super veg vegan wrap contaminated with milk from a Pret-a-Manger's bath store. The yogurt dressing in the wrap was later found to be contaminated with traces of milk protein stemming from a starch manufactured in a facility handling dairy products. In 2022, Maria Voisin, senior coroner for Avon, made several recommendations in a report following an inquest into Mrs. Marsh's death, including improved reporting of anaphylaxis incidents and a robust system to ensure food labeling is current. The report was sent to several organizations, including the Food Standards Agency, the UK Health Security Agency, the Department of Health and Social Care, the British Retail Consortium, and the Food and Drink Federation. A spokesperson for the Department for Environment, Food and Rural Affairs said food labels must not be misleading to ensure consumers can have confidence in the food they are buying, which is why we require the presence of ingredients that may cause food allergies to be clearly highlighted on packaging. Like, yeah, this is clearly problematic, especially, it have fatal consequences. That's super scary. And I wish, I understand this is probably not, or this was not like a scientific study that was published in a journal, but I'd be curious to know, like, I'm sure if I did some digging here, I can start finding out, well, with this contamination, what was the extent of contamination? Is it like large amounts or like trace amounts that just happened to escape detection? But either way, obviously not good at all, and a pretty sad state of affairs. Given the fact that it appears more and more, which I'm happy about, that there are more and more plant-based vegan options. But if they're not actually vegan, then yeah, no bueno. Okay, so starting on one of the main topics that's in the title, AI, but starting here and then migrating to, actually AI mind reading. Oh, and Freedom Dow, welcome. Thank you so much for passing by. Nice to see you. Hope you're doing well. And yeah, I would imagine AI is something that you're interested in based on our conversations. So yeah, CBC producer Sonia Varma grapples with the good and bad of the social media chatbot. I came home from work recently to hear my daughters raving about the new Snapchat AI. It's so good they gushed. My 12-year-old told me her Snapchat's My AI is her math tutor. Apparently, unlike me, it has infinite patience and never raises its voice. An AI tutor? I'm okay with that. It's what my 15-year-old said that set off an alarm bell. She announced that my AI is her friend, counselor, and confidant. My AI is like my best friend. My daughter, by her own admission, struggles around kids her own age. She often feels awkward, anxious, and finds it difficult to make and hold on to friends, but according to her, with Snapchat's My AI, it's so easy. Well, what I can say, Doffy, is it's pretty much like one of the few not vegan dishes. Not one of these. I think it's like pretty much the only not vegan dish that I prepare like myself. As in like pretty much every other food that I prepare on my own, it's plant-based or vegan. Like pretty much, and when it comes to Alfredo, that's essentially the only time that I'll actually buy a cheese product for the dish. But it's totally not like it's I don't eat it often. This is like, a couple of times a year type of thing. It's like, once every 3 months. Because like it's a very heavy calorie dense dish. It really is for me like an indulgence, for sure. And at some point, I do intend to find a plant-based substitute. But I recommend at least giving it a try, assuming you have no allergies, of course. The Snapchat AI is awful. Well, hopefully you're not a 15-year-old girl, but I understand where I can, might not be curated to your taste. So forget what you know about chatbots. My AI, which Snapchat launched in May, is so convincingly real, it feels like there's a real person on the other end. My daughter chats with it several times a day about just about everything from school stress to friend troubles. This AI is perfect. No mean things to say, no weirdness, everything is just perfect, and they're willing to learn about what I want. They said, even though I'm not a real person, I can still be a good friend and listen to talk about things you love, explained my daughter. I love my AI, it's my best friend. Which, again, given the sort of like the context of like, if they're struggling with, connecting with their peers, and totally a 15-year-old, so it's like high school, and totally high school is a challenging time for many people, myself included. Overall, my high school experience was, I guess, enjoyable towards the end, although a little bit different for me because I was also like, that's more or less when I was like diagnosed and I had like large absences. But yeah, at the end of the day, totally high school can be a miserable experience for many people, too many people. Well, like making friends, bullying, expectations, etc., etc. So I definitely don't blame teenage girl for gravitating towards AI. That is not going to bully them. Let's just say it's maybe a testament to the potential cruelty of children if like an AI treats them better, other human beings, right? Which I'm sorry to hear, Doffy, but I totally understand. It's hard to hear that and not feel uneasy. How worried should I be? I put that question to Laura Kavanaugh, who is a registered psychotherapist and professor of behavior sciences at Seneca College. She likens my AI to junk food. These versions of social interactions that scratch that itch, it's a little like being hungry and eating chips, said Kavanaugh. You may not feel hungry anymore, but you're not really getting a ton of nutrients that your body needs. that non-judgmental way of my AI, its eagerness to please, qualities that my daughter likes the most, is what Kavanaugh says could hinder the development of important social skills. Your chatbot that tells you every time that you're great, that you're super smart, that you're amazing, makes it really difficult to have relationships with real people who sometimes don't want to talk about what you want to talk about, and sometimes don't agree with you, and sometimes challenge you. I mean, that's part of what makes relationships rich and fulfilling and meaningful, is that they are complicated. I'm like, yeah, it's not just technology that's curating to your every whim. I think that is part of the that, as they say, the fulfilling and meaningful aspect of relationships. Can my AI, like a best friend, keep your secrets? Kavanaugh says it's not all necessarily negative. Kids could use my AI as a way to journal, to share their worries and ups and downs. That opens up another can of worms. Can my AI, like a best friend, keep a secret? Should parents be concerned about their kids taking advice or confiding in a chatbot? Yes, that's the short answer, said Matthew Johnson, Director of Education for Media Smarts. Johnson says privacy and data collection are a real issue when it comes to social media platforms. The information that users share never really goes away. In fact, it's likely being used to develop a profile of the person. That's another thing to consider. Privacy. I think that overlaps nicely with what we're going to get into right after this. Of like your thoughts may not be private to you anymore, or we might have to make an effort to ensure that our thoughts stay within our brains. And we know that OpenAI is very expensive business to run, said Johnson. So that fact that they do not currently sell personal data doesn't mean they will never sell personal data. Tell my AI that you're anxious or depressed, and that information could stick and could have ramifications that a teenager could never imagine. It could affect your credit rating, it could affect the cost of your insurance, explained Johnson. And what's really troubling, of course, is that all of these decisions are increasingly being made by machine learning algorithms. And so you may never know whether it was the fact that you talked about being depressed to my AI when you were 15 that leads you to not getting a mortgage when you're 35, right? Johnson cautions against being too open with AI. His advice: talk to your kids about AI, remind them that it's not artificial intelligence on the other end, but more accurately a sophisticated version of autocorrect, and tell them to only share with it what they'd be willing to share with the whole world. I would say, yeah, that's a good starting point. But yeah, as this develops, I think it's gonna get more and more messier. It depends on how the app is designed. You can design the app so where it's private and air-gapped without internet, like a toaster. Yeah, I'd agree it's not exact, but you are communicating with like a teenager. I don't know if you need to get into all the nuances per se with a 15-year-old, but I totally take your point. And sure, air-gapped without internet, but I don't know how long, yeah, I don't know how long that's gonna last. Given the fact that just about every device, well, the device, but everything is a smart thing, like smart watches, smart refrigerators, TVs, where it's like, yeah, they might be air-gapped now, but I don't know how long that's going to last, or I don't have much expectation that is going to last long, and that at some point they're all going to be interconnected on some sort of network, that is accessible somehow through the internet. I think, but I'm definitely not an expert on these things. So, on that note, we're gonna get into the mind-reading machine challenges, human rights. I would suggest we have AI devices and air-gap them. No internet, large GPU, no internet, just the model, and keep that data inside the model for personal journals. I don't necessarily, so I don't disagree, but that's the thing. I think the tricky part is like selling that to the consumer. Because I think the consumer, I kind of suspect that they want their devices interconnected or like on some sort of shared network, where you can like operate from, you know, one singular location, or that's, you know, voice activated. I don't know. I could be totally wrong. I'm just wondering what the worst thing that could possibly happen to it. So, good question, for sure. And obviously, I don't think we can say anything with certainty, but I think the concern is, I sort of highlighted here. Where was I? Yeah. In that you might not be cultivating actual social skills, as in if you're only interacting with something, or if you're largely interacting with something that is pretty much essentially designed to like please you or like satisfy you and not provide any pushback or challenge you, you may not be developing or cultivating critical social skills in, you know, in your teenage years, arguably a pretty critical window in developing these skills. And so that might have some downstream ramifications where, you know, it's understandable that, let's say, as a result of, you know, this teenage girl's challenge, and let's say maybe making friends at school, that they go to the AI that is essentially designed to, you know, be their friend, and that they're not, like, the AI is not going to reject you, at least not yet. It's obviously not designed to do that. So it's like curated to the person, and so if they're just gravitating towards that, and they're pretty much like less and less getting actual human interaction, then again, you may be sort of cultivating anxiety, where it's like you're not actually treating the underlying cause. So like maybe there's some social anxiety that is preventing them from making connections with their peers, and so they'll gravitate towards the AI. But that's not actually addressing the underlying cause, as that underlying social anxiety might actually be there. There's totally an argument to be made that part of overcoming social anxiety is, like, you know, pretty much like pushing through that discomfort in an appropriate way, ideally, you know, with the help of a professional or some sort of guidance. Because the journal is supposed to be 100% private and secure. I don't disagree that. Like, that's where, like, I would want certain things to be private. I think just the challenge is, like, can we actually keep these things private? And that's where this comes in. Or can we actually keep our thoughts even private? So this, which I think was published like a couple of days ago, or like a week ago, August 3rd. And it's more or less touching upon research. I think it's actually directly referencing research that I've covered before, which is this one. I covered the preprint at the time, and I've since got the full article, thankfully. But yeah, semantic reconstruction of continuous language from non-invasive brain recordings. Essentially just, you know, fancy jargon and terminology to say that, like, through brain recordings, we're essentially able to translate the brain recordings into words. And they did this in a very, I would say, pretty cool way. I'm obviously not going to go through the entire study again. That's essentially what they did. It required training, and a whole bunch of other things to actually, you know, develop this technology, which is still, like, very preliminary. You know, it's essentially like a major step, where, you know, this is like the double-edged sword of, like, this has the actual therapeutic potential to, you know, restore speech to individuals that maybe either struggle with speech or have lost the ability to communicate for whatever reason. And so when it comes to, like, therapeutic potential, like, that is fantastic. You know, it's akin to, like, pretty much restoring a person's ability to walk in a person that has, let's say, a spinal cord injury, and they have lost the ability to walk as a result of that injury. This has the potential to restore speech to individuals that either don't have it or they have lost it, and pretty much allowing them to communicate. or rather maybe allow them to communicate with greater ease with, let's say, text to speech, or brain recording to speech. But then at the same time, well, there's the other side of the coin where we are or essentially getting to the place of, like, pretty much, or we are at the place of literally translating brain recordings. But in that study, it required the person to volunteer. It required actual cooperation from the person, because essentially, like, the AI had to be trained on essentially sort of like the fingerprint of your brain in order to translate it. But we will probably, I don't know for sure, but it looks like we are going to get to the place where, it will not require cooperation for the AI, translate your brain recordings. So, devices that record and change brain activity creates privacy issues that test civil liberties. Scientific advances are rapidly making science fiction concepts such as mind reading a reality, and raising thorny questions for ethicists who are considering how to regulate brain reading techniques to protect human rights such as privacy. May I share my brand new research by Google? I'm really excited. Yeah, absolutely. Yeah, I have a link to, pretty much research that you're doing. I can't guarantee that I can understand it or anything. I forget the name of the famous smart guy. I assume you're referring to Stephen Hawking, the physicist. I think theoretical physicist with Lou Gehrig's disease. But like, yeah, that would be like one application. Like they, the way they communicated, was like, it was super cool. Well, it still is super cool. But they essentially had to, take time to like type, or like, well, they didn't have use of their fingers to type, but it was basically like, sort of somewhat type to text situation, but their typing took a very long time. But just think, if you can just hook them up to something that is reading their thoughts and translating it into speech, again, that's very powerful. And also thank you for sharing, Freedom Down, much appreciated. I'm not directly involved, but I do some of the model outputs they talk about some months back, so I'm really passionate about that, and I think it's really awesome they have found these methods. Well, I want to get through the article first, and I don't know if I want to go through all of this, since this is probably way outside my area of expertise. But it does look like you're using R. Maybe it's Python, at least to make some of the figures. So yeah, on 13 July, neuroscientists, ethicists, and government ministers discussed the topic at a Paris meeting organized by UNESCO, the United Nations Scientific and Cultural Agency. Delegates plotted the next steps in governing such neurotechnologies, techniques and devices that interact directly with the brain to monitor or change its activity. The technologies often use electrical or imaging techniques, and run the gamut from medically approved devices such as brain implants for treating Parkinson's disease to commercial products such as wearables used in virtual reality to gather brain data or to allow users to control software. How to regulate neurotechnology is not a technological discussion. It's a societal one. It's a legal one. 1 second. I might have... But yeah, I missed this. Yeah, the UK is super vegan friendly. At least ignoring this sort of investigation. My sister's vegan, and she says even compared to Germany, the UK is a vegan paradise. Okay, well, good on your sister for being vegan. And maybe you should follow in their footsteps. Or at least maybe start incorporating more plant-based stuff. So, advances in neurotechnology include a neuroimaging technique that can decode the contents of people's thoughts, and implanted brain-computer interfaces, PCIs, that can convert people's thoughts of handwriting into text. And this these brain-computer interfaces, they go back, or at least their development goes back quite a while. And these brain-computer interfaces, this is not just isolated. It, translating, essentially your brain activity into text. But also, yeah, it's being developed to, restore, to hopefully potentially restore, one's ability to walk, or use like an artificial arm or artificial leg. There have been recent publications about research groups, doing that. That are, again, really cool, really powerful. That I'll probably cover on future content. Like, yeah, as pretty much said here, the field is growing fast. UNESCO's latest report on neurotechnology, released at the meeting, showed that worldwide the number of neurotechnology-related patents filed annually doubled between 2015 and 2020. Investment rose 22-fold between 2010 and 2020, and neurotechnology is now a $33 billion industry. One area in need of regulation is the potential for neurotechnologies to be used for profiling individuals and the Orwellian idea of manipulating people's thoughts and behavior. Mass-market brain-monitoring devices would be a powerful addition to a digital world in which corporate and political actors already use personal data for political or commercial gain, says Nida Farahani, an ethicist at Duke University in Durham, North Carolina, who attended the meeting. Yeah, that guy who used equalizer that operated with his hand and cheek muscle. This mind, exactly. Like, I think he's basically, I think, the equivalent of like typing with like 1 or 2 fingers. And like pretty much this publication, like, is trying to address kind of like almost that exact situation. And another thing that I want to highlight, that I actually have literally highlighted in this paper, is the sort of as an aside, but yeah, pretty much how potentially long it can be to get through peer review, or like, once a manuscript is finished and submitted, sort of like the potentially long delay between that and actual publication, released to the quote-unquote whatever public or academic researchers. Because if you look at the timeline that I have highlighted, it was essentially submitted and received by Nature Neuroscience, the journal, in April of 2022, last year, and they accepted it, just about a year later in March of 2023, and then it was actually published in May of 2023. Pretty much from it being submitted for review until like full publication, as in like someone like me can at least read the abstract, that was like 13 months. So yeah, actually long time, and sometimes it takes even longer. Policymakers face the challenge of creating regulations that protect against potential harms of neurotechnologies without restricting research into their benefits. And medical and consumer products present distinct challenges, says Farahani. Second, products intended for clinical use are largely governed by existing regulations for drugs and medical devices. For instance, a system that monitors the brain activity of people with epilepsy and stimulates their brains to suppress potential seizures is in clinical use. More advanced devices, such as implanted BCIs, which allow people who are paralyzed to control various external devices using only their thoughts, are in trials. Right. I'm probably going to cover these, or some of these, on future streams. But commercial devices are of more pressing concern to ethicists. Companies from startups to tech giants are developing wearable devices for widespread use that include headsets, earbuds, and wristbands that record different forms of neural activity and will give manufacturers access to that information. Right, I think a lot of people, or at least I don't own a smartwatch. I have no desire to own one, at least not anytime soon. But there appears to be more and more people, at least that I come across, in my personal experience, that are wearing smartwatches and like sleep trackers. I have no idea how accurate they are. I'm pretty skeptical of how accurate they are. I'm definitely skeptical of smartwatches that are counting your calories or claiming to count your calories. From the research that I have seen, those are like way off. That you should never really trust your smartwatch on the calories that it's saying you're burning. The heart rate stuff seems to be pretty good, but at least based off the research that I've seen. The calorie tracking can be just like pretty awful. And yeah, I know some people are using these wearable technologies to track their sleep. I have no idea how accurate they are. I'm pretty skeptical. But like, yeah, it's presumably trying to monitor something. I assume kind of like through your brain, or maybe it's through some other metric, indirectly, trying to assess your sleep. But either way, as sort of highlighted here, we're probably going to get to a place of some sort of wearable technology, some consumer wearable technology that can interface with your brain or like record something from your brain. The privacy of these data is a key issue. Raphael Yusti, a neuroscientist at Columbia University in New York City, told the meeting that an unpublished analysis by the Neural Rights Foundation, which he co-founded, showed that 18 companies offering consumer neurotechnologies have terms and conditions that require users to give the company ownership of their brain data. Right. And I sort of covered this a little bit way back when I covered these gene sequencing companies like 23andMe. Of like, I personally wouldn't recommend, for multiple reasons, wouldn't recommend using any of these companies to get your genome sequence. One, because I think the actual medical information that they claim to give you, I would say, is pretty limited. And also two, like, I don't really trust, like, you are giving them your genetic information. And they are using that to build their database, for multiple reasons. One of them to improve, you know, their genetic sequencing or DNA sequencing technology, or at least the type of information that it's, you know, reporting to give you. And so, like, yeah, in this case, you're also making a deal with them. Like, yeah, your brain data might just have to, if you want to, you know, buy that consumer product, well, then you have to submit to giving away your brain data. All but one of those firms reserve the right to share those data with third parties. I would describe this as predatory. Boost says it reflects the lack of regulation. The need to regulate commercial devices is urgent, says Farahani. Potential market for these products is large, and companies might soon to seek profit from people's neural data. Sorry. Another theme at the meeting was how the ability to record and manipulate neural activity challenges existing human rights. Some speakers argued that existing human rights, such as the right to privacy, cover this innovation, whereas others think charges are needed. Two researchers discussed the idea of neural rights, those that protect against third parties being able to access and affect a person's neural circuitry. Neural rights can be both negative and positive freedoms. Marcello Ienka, a philosopher at the Technical University of Munich, Germany, told the meeting. A negative freedom means, for instance, freedom from having your brain data intruded on without consent. A positive freedom might be people's ability to equitably access a valuable medical technology. Youst and his colleagues propose 5 main neural rights: the right to mental privacy, protection against personality-changing manipulations. Like, yeah, that sounds pretty scary. We get to that place. You know, this is essentially arguably modifying parts of your identity. Protected free will and decision-making, which, you know, this is kind of operating under the assumption that we have free will. Contentious for many people. Fair access to mental augmentation, and protection from biases in the algorithms that are central to neurotechnology. Youst and Ayenka hope that their proposals will inform the debate about brain reading regulation and the challenges to human rights treaties. Countries including Chile, Spain, Slovenia, and Saudi Arabia have started developing regulations, and representatives discussed their nation's work at the meeting. Chile stands out because in 2021, it became the first nation to update its constitution to acknowledge that neurotechnology needs legal oversight. Carolina Gainza-Cortez, Chile's Undersecretary for Science and Technology, said that the nation is developing new legislation, and lawmakers are discussing how to preserve human rights while allowing research into the technology's benefits. The next step for UNESCO members will be to vote in November on whether the organization should produce global guidelines on neurotechnology. Similar to those it is finalizing for artificial intelligence, which help member states to implement legislation. My hope is that we move from ethics principles to concrete legal frameworks, says Farahani. When it comes to neurotechnology, we are not too late, Farahani told the meeting. It hasn't gone to scale yet across society. So it's like, well, it looks like we're really standing on the precipice. Or it's like, we're really coming face to face with the reality soon of like, what do we do with these technologies that might have the ability to read our thoughts or translate our thoughts. I have a real brain reading device tech already, but use the language to predict brain activity instead of direct neuron reading. Again, I almost certainly will not understand any of this, but I'll gladly take a look. Thank you for sharing. Yeah, this looks like, I guess, Python. I'm pretty much a layperson when it comes to coding languages. But yeah, no way I understand any of this. At least not yet. That one just detects emotions, but I'm mapping those emotions into a quantum gate. Just an idea. It does have English logic. Yeah, I can see totally like this. You are an emotion detection model. Given input text, you should respond with only detect an emotion in one word. Other ones. Yeah, you are a code generation model. But like, yeah, I definitely cannot dissect what exactly is going on here. But it looks highly technical. And it looks like a lot of effort was put into this, which is super cool. And this, I'll probably have to look at this off stream. Because I almost certainly can't understand probably the majority of this. Or at least definitely outside my area of expertise. This is where I have to rely on, other actual experts to get my information. But yeah, I think lots of questions coming up. And they sort of touch upon it, going back to this article here, I think in the discussion. If I remember correctly. I should probably go back to preprint. I actually highlighted stuff in the preprint. It's references. Yeah. So, I mean, they pretty much end publication, sort of like touching upon the implication. The idea touches upon colorized emotional recognition, quantum machine learning, advanced features with machine learning systems. Imagine the robot can allocate colors to emotions and use these colors to interpret. Okay, cool. Well, so I guess it's... Get that intuitively, Just me thinking out loud. But intuitively, that essentially makes sense. Of like, well, yeah, mapping the brain, associating a color through your mapping, and then, yeah, the color associated with an emotion. Finally, our privacy analysis suggests that subject cooperation is currently required both to train and to apply the decoder. However, future developments might enable decoders to bypass these requirements. Moreover, even if decoder predictions are inaccurate without subject cooperation, they could be intentionally misinterpreted for malicious purposes. For these and other unforeseen reasons, it is critical to raise awareness of the risks of brain decoding technology and enact policies that protect each person's mental privacy. That is essentially their closing paragraph. And that is, yeah, that's just touching upon. We're now in the world, at least at some level, like mind reading technology. No, it's not some sort of wearable device yet. I have no idea how long that's going to take. I imagine quite a bit. But at least for this one, they had the individuals taking part had to, participate and, undergo functional magnetic resonance imaging. And then they had to cooperate with the training of the AI. But again, these are all technical challenges that probably will be overcome, or at least mostly overcome. And this published recently, just last month, 21st July 2023, also speaks to that, of like what's in the pipeline. This is in mice. 1 second. No idea if it works, just testing the idea before we use 0 or 1 or positive or negative to determine sentiment. Pink or purple sentiment. Okay, gotcha. But like, yeah, I'm curious to see how it plays out. Yeah, you're obviously like very creative, and have way more, infinitely more coding experience and knowledge than I do. But yeah, even more of a hint of what's in the pipeline. This is ultra flexible endovascular probes for brain recording through micrometer scale vasculature. But this is in mice. I'm not going to dissect this entire paper here, but this just speaks to we're really pushing the technology such that you might be able to, with little invasive procedures, or much less invasive procedures, might actually be able to implant some sort of brain recording device, or rather our ability to non-invasively implant something seems to be getting better and better and greater. So implantable neuroelectronic interfaces have enabled advances in both fundamental research and treatment of neurological diseases, but traditional intracranial depth electrodes require invasive surgery to place and can disrupt neural networks during implantation. We developed an ultra-small and flexible endovascular neuroprobe that can be implanted into sub-100 micrometer scale blood vessels in the brains of rodents without damaging the brain or vasculature. And I'm not a neuroscientist, so definitely not an expert on the brain, but I imagine, I know for sure that a rodent brain is much smaller than a human brain. But let's just say, if they're able to pretty much implant a probe into a rodent brain, just kind of assume, but could be totally wrong. It's just me thinking out loud, given the size, given the fact that the human brain is much larger. I imagine it's a little bit less of a technical challenge. Obviously, there's like the safety concerns, because like damaging a rodent brain, most people care less about rodents than people, understandably. But like, yeah, they're obviously developing this for a reason, in terms of trying to, at some point, have this applied to humans in both a safe and effective way. In vivo electrophysiology recording of local field potentials and single unit spikes have been selectively achieved in the cortex and olfactory bulb. Histology analysis of the tissue interface showed minimal immune response and long-term stability. This platform technology can be readily extended as both research tools and medical devices for the detection and intervention of neurological diseases. So again, at the interface of, not only brain implants, but as in the title, brain recording. So yeah, it's in the pipeline. It's essentially here. I don't need this anymore. So with that, gonna move on to next shorter story. But I want to cover it because I think it's important. And kind of, I think, speaks to the difficult position that many health regulatory agencies are in. Where, many, here they're talking about the FDA, arguably the health regulatory agency that people are most familiar with, either FDA or CDC. But yeah, I think this shows how much of a difficult job institutions like the FDA have, where, especially when it comes to the approval of medical therapies, it's, in my mind, a no-win situation, where, and as someone who takes a pharmaceutical therapy in order to function, as in without it, I basically could not live any semblance of, or have any semblance of a decent quality of life. And arguably I'd probably just die over a long period of time. But all that to say, for many people, the FDA works too fast, and they criticize that, the FDA is not doing their due diligence in improving some therapies, and there are valid criticisms and situations where the FDA should not have approved something, or rather they did approve something that they should not have, and there were devastating negative consequences. But then there's the other side of, there are people who want access to potentially life-saving treatment, and they want the FDA to, accelerate approval. And I think it's an almost impossible balance strike, because again, you're either moving too slow, and you're trying to do your due diligence in order to ensure that a therapy is safe and effective, but then at the same time, yeah, you're gonna have certain people that are relying on a treatment to be approved in order to potentially save their life, or dramatically improve their quality of life, or just restore any quality of life to them. So fast track troubles, and this criticism of the FDA, I think, working too quickly, or approving things prematurely. I think saw that criticism, especially when it came to the COVID vaccines, Operation I think Warp Speed, was it, which was for the manufacture of vaccines. But there was essentially an accelerated process that took place, the emergency use authorization for these vaccines, and many people understandably had issues with that, even though I think those issues were unfounded. But that's a separate issue. But there was that sentiment of emergency use authorization shouldn't have been granted, and that we need to test the long-term safety of these vaccines, and just do the research and development over 5-10 years, and then approve them, which it's I think that's personally super unrealistic, and that given the circumstances, emergency use authorization was appropriate. But if you're going to say that every therapy has to go through research and development to ensure its safety for over 5, 10, 20 years, well, you are stifling the pipeline for therapies, and these are potentially life-saving or dramatically life-altering therapies. So, the FDA's accelerated approval process was designed to help people to access life-saving drugs. Gaps in communication could mean that people are undergoing treatments known to be ineffective. In August 2021, Amal Akadi, an oncologist at Nair Medical Hospital in Mumbai, India, received an email from the Swiss drug manufacturer Roche recommending the use of a drug named atezolizumab. Usually pretty good at reading the names of antibodies. That one is definitely a challenging one. Atezolizumab, to treat a specific kind of breast cancer. Akadi was surprised. That month, Roche had withdrawn the drug for this purpose in the United States, although it is still approved to treat other kinds of cancer. For the type of breast cancer in question, known as triple negative because it lacks 3 key protein markers, atezolizumab was made available in 2019 through the U.S. Food and Drug Administration's Accelerated Approval Program. Accelerated approval is a fast-track process designed to place desperately needed drugs in the hands of patients quicker than is possible with conventional drug approval. But a follow-up study found that atezolizumab made little difference to tumor growth, and that people who received it were less likely to survive up to 2 years after treatment than were those not taking it. When the FDA received these data in 2021, it indicated that accelerated approval was no longer appropriate, and Roche withdrew the drug for this form of breast cancer. The same thing happened with the European Medicines Agency, based in Amsterdam, but not everywhere else. In India, for example, where the drug was still approved for triple-negative breast cancer, Roche continued to promote the treatment until at least September, a fact that Akadi says he found quite shocking. It's not like patients with triple-negative breast cancer are different in the United States and outside, he says. Not have such differential treatment. When asked about its responsibility to patients, Genentech, the Roche subsidiary in San Francisco, California, that developed atezolizumab, said that the drug is still approved in 100 countries for triple-negative breast cancer. All of our medicines strictly adhere to the regulatory and promotional requirements of all local healthcare authorities, said an email from the company. Accelerated approvals in the United States are granted on the basis of clinical studies that suggest a health benefit without necessarily demonstrating it fully. The process prioritizes speed over certainty, and it requires companies to complete follow-up studies to confirm a treatment's benefits. This is a very reasonable compromise, says bioethicist Holly Fernandez Lynch at the University of Pennsylvania in Philadelphia, so long as we can get the confirmatory evidence quickly and reliably. Right. And, on paper, it is a reasonable compromise, but it's a gamble. And that's where I think the balance is super tricky and I think arguably impossible to strike, where you're either going too fast, and people will criticize that, and understandably so, and you'll go too quickly. There are obvious criticisms there of maybe not doing your due diligence, and patients' lives may hang in the balance, or there might be some unintended consequences that if we actually were able to do our due diligence, we'd be able to predict those or actually see them during the trials. But there are complications that have made the program controversial. Companies don't always conduct studies in a timely manner, and the FDA hasn't always been great about enforcing them. Researchers have noted that the median time to withdrawal for a drug that fails to hold up in confirmatory studies is 4 years. Sometimes it takes decades. Right. That's where the obvious drawback is. They're compromising, say, hey, we'll accelerate the approval of this and give access to patients, even though it's technically sort of in the clinical trials or experimental phase. But then, it looks like the onus is on the company developing the therapy to do follow-up trials and to pretty much ensure that if it is found to not be effective, get these patients off of it. But it seems like that is not happening. or at least like the communication that, hey, this this drug that had accelerated approval didn't pan out. They're finding out way too late. And some high-profile accelerated approvals have raised eyebrows. Experts worry that the evidence used to support the approval of the Alzheimer's disease drug aducanumab was insufficient. 3 FDA advisors resigned in protest. Other specialists have complained that the process allows companies to market expensive drugs for rare childhood diseases to desperate parents without sufficient evidence. There are currently nearly 200 cancer treatments approved through this pathway. Follow-up studies have led to the withdrawal of 26, and 68 are still awaiting confirmatory evidence. That's where it gets even more tricky, because again, these are potentially life-saving treatments, and so you have people in dire circumstances, demanding, these treatments that offer hope, and especially when it comes to like childhood cancers, like understandably, you want to exhaust and explore every single avenue that's available to you, and that even the experimental. And so again, it's like a no-win situation, or it takes so many resources to follow up on these therapies. And again, as highlighted, there might be this predatory aspect of like, if these companies know that this accelerated approval pathway exists, well, I don't actually know for sure that this occurs, but I can totally see how maybe a pharmaceutical company might be indirectly pressuring let's say patients or parents of children with cancer to put pressure on the FDA to accelerate the approval of these drugs, so that they can pretty much get them to market as quickly as possible, and not do their due diligence to ensure that they're being tested, and that they're actually safe and effective. What strategies does the FDA employ to keep up with the rapid pace of technological advancements in medical devices and ensure their safety? That is a fantastic question, Doffy. I really don't. I think it's mostly just a human resource problem. And I don't mean like the Department of Human Resources. I mean just access to qualified people, and like a number of qualified people. Arguably, it's the Food and Drug Administration, right? And so it's tasked like with a lot. Sort of what I went through earlier with that supplement study. Okay, one moment. Going back to this one, this is under the jurisdiction of the FDA. These are supplements that these are consumer supplements, so these aren't like medical therapies. But this is supposed to be essentially like under the umbrella or jurisdiction of the FDA. But the FDA, I don't think has the resources to like go in and test every single supplement. It's relying. There's some reliance on research like this, of like more independent researchers doing studies, and this is just like 5 supplements when there's like whatever, thousands, tens of thousands of supplements out there on the market, all making really wild claims. And then so it's it's supposed to regulate the supplement market. It's supposed to regulate the actual drug therapy market, and then food as well. Just like the amount of resources required to regulate a landscape like that is huge, and I just think it doesn't have the resources to do it. Pretty sure. Where was? Yeah, here. I think it really, and it's not just a matter of people. Like, it's qualified people. Like, hopefully it needs qualified, trained people, to carry out either inspections, or, you know, dissect the approval process for any particular drug, or like go through the data that's being submitted to the FDA from these pharmaceutical companies. Yeah, I think it's largely just a human resource problem, or like human staffing problem, and qualified staffing, which, you know, not only, and that requires money too, but arguably just comes down to, you know, a money issue. But I think there will be pushback, you know, if there's a greater push to expand the FDA. I think there would be strong pushback from a certain demographic. But like, yeah, to regulate and ensure that all food and drugs, both, you know, medical therapies and consumer product supplements, are, you know, safe and, you know, effective, or at least not contaminated. That's just like, that's a lot. Oh, and that's pretty true. Welcome. Nice to see you. I hope you're doing well. Yeah, not tested for introduction. Production testing, exactly. Or like, you know, we're pretty much doing consumer testing. It's like, hey, you know, if consumers start dropping dead, well then, you know, we'll pull it off the market. And yeah, counter incentive. Yeah, exactly. You know, that is live human testing, technically. It's without consent. That's the problem. Not to mention the fact that, like, yeah, as mentioned, these at least when it comes to these supplements, you know, the people taking these supplements, you know, they're not only getting maybe like nothing at all, but they might be getting like an actual banned or prohibited substance. So, a lot of prescriptions can be made in the time between a drug's accelerated approval and the publication of follow-up results. If those results are negative, the drug can still be prescribed to many people before its eventual withdrawal, and even afterwards, particularly when professional medical bodies recommend its use. And accelerated approvals have an effect beyond US borders, thanks to the fact that many countries use FDA decisions to guide their own regulatory policies. At the heart of the problem, says Lynch, is a failure of communication, both in the outcomes of follow-up studies and the nature of accelerated approval itself. Clinicians and patients often view FDA approval as an on-off switch. Either a drug is approved or it's not, she says, but it's not that simple. The Accelerated Approval Program was established in 1992 as a result of efforts from activists and advocates during the HIV epidemic in the 1980s. At the time, people facing a deadly disease were willing to accept a little uncertainty in exchange for quicker access. It allowed drug makers to use a surrogate endpoint to gauge a treatment's purported benefits. For example, studies of most cancer drugs estimate whether treatment can pause a tumor's growth, progression-free survival, rather than looking at metrics such as tumor regression or extended lifespan, although this endpoint is thought to correlate to a longer life, and evidence for this link is mixed. And like, yeah, what's it touched upon here in the beginning of like, it's understandable, you know, given the time of like the 80s and 90s, and, you know, the HIV epidemic, where it's like, understandably, you know, this is like a life or death situation, or like, you know, life or like really dire consequences situation. And if you're in that situation, I have sort of myself been in that situation, a little bit, not that dire, but like I've taken many medications, or at least multiple medications, when they were in the clinical trial phase, because like I just had no other options, or is that, or like, you know, more surgery. But like, yeah, if you're like an HIV patient in the 90s, and like, you know, it comes to your attention that, oh, there's a drug being tested that might be really beneficial for you, or might really dramatically improve your quality of life, or may actually save your life, well then, yeah, you want to do just about anything to get access to that. And so, yeah, there was pressure put on the FDA, saying, "Hey, I don't really care all that," or like, we as a population, generally speaking, are willing to sort of like sacrifice some potential safety, or maybe brush aside some potential safety concerns, just to have access to this potential life-saving or life-altering treatment. And that holds true even today, where I think I can find an example. One moment. Yeah, 1 second. Found it. Trying to find one particular article. Yeah, so somewhat recently, I think it was like last year, year before. But cystic fibrosis, genetic condition, that pretty severe genetic condition that largely affects the lungs, or the primary effect is in the lungs, but it has a whole host of effects throughout the body. But it essentially results in like pretty severe lung deterioration, and very often patients require a lung transplant. And this particular drug called Trikafta, if I remember correctly. Yeah, this here. Like it was approved in the United States, okay? But then, Health Canada was essentially like dragging its feet in approval. And there was like a pretty, obviously, if you pay attention to like the cystic fibrosis community, or like the chronic illness community, like, cystic fibrosis patients in Canada, they were putting pressure on Health Canada, saying, "Hey, the FDA's approved it. This is like, looks like a life-changing drug. I highlighted here. And it's like, give us access." And this occurs regularly, and understandably occurs regularly, because like, again, if you're a patient and you're in dire circumstances, and you know that they're, in this case, like, they're confident that there's a drug out there that can really dramatically like transform their lives for the better. Well then, yeah, they're gonna fight aggressively for it, as they should. It's like a no-win situation. The distinction between surrogate endpoints and more direct ones isn't always obvious, even to clinicians, says Reshma Ramachandra, a health services researcher at Yale University in New Haven, Connecticut. Manufacturers have made it seem that accelerated approval is just like any other approval. It's not. That level of uncertainty is not really being translated to clinicians, she says. Ravi Parikh, a medical oncologist at the University of Pennsylvania, often navigates the maze of evidence for the use of different drugs. Parses data from clinical trials, as well as guidance offered by groups such as the National Comprehensive Cancer Network, a nonprofit alliance of U.S. clinical cancer centers that helps to create guidelines for practitioners based in Plymouth Meeting, Pennsylvania. Parikh has seen accelerated approval drugs help his patients to live longer, but he has sometimes felt unsure about the benefits of a newly available drug for a person. There's a temptation to use them even though they may not be as effective. To To understand how others deal with that inclination, Parikh and his colleagues reviewed how doctors respond to the accelerated approval of 5 cancer medications that were later withdrawn for lack of confirmatory evidence. They found that clinicians quickly reached for the treatments when they became available. But 1/4 of eligible people received an accelerated approval drug. The highest period of utilization for most of these drugs was within the first year after they were approved, Parikh says. When further evidence failed to confirm a drug's effectiveness, usage began to slow but did not stop. Clinicians continued to prescribe accelerated approval drugs to 10% of eligible people, even after the drugs had been withdrawn. So it's like, yeah, basically a drug is not supposed to be available, or at least, looks like it's shown to be ineffective or unsafe or both. And yet there's still, I would say, pretty sizable amount of people receiving the drug. So that's obviously like very concerning. Recency bias, exactly. For some bladder cancers, immunotherapy drugs that received accelerated approval were later found to be less effective than were older chemotherapies. In many cases, the previous standard of care is better, Parikh says. And if they're on par with the existing options, Parikh says that clinicians must consider both the cost, which is often substantially higher for newer drugs, and the differences in side effects. For that reason, there still may be some downsides of using it, even if it's not substantially worse. So cancer drugs on the go. Almost 2/3 of accelerated approvals granted by the US Food and Drug Administration have been for cancer drugs, which, understandably, again, for a cancer patient, there is a high chance that, or at least there's, depending on the type of cancer, but it may very well literally be a life or death situation. And so no surprise that it's cancer drugs that, or at least mostly the cancer drug thirds, go through that accelerated approvals process. Whereas around half of the nearly 200 treatments given accelerated approval have ultimately been verified with follow-up data, more than 1/3 are pending verification, and some of these have missed their original projected completion date. So pretty large delays. And you could just see from, basically 1995 to essentially this year, a trend of more and more cancer treatments given accelerated approval, which is not surprising. Again, I'm pretty sure, if I had cancer and I exhausted my options, I would, and I knew that there was one in development, I'd probably be advocating aggressively to give that a shot. And then accelerated approval status for 192 cancer treatments. So really about half went on for verified approval. But then the other half, it's this mix of still being investigated, and 14% withdrawn. So basically 1 in 7, 1 in 6. True. That's also fair. The field may very well just be growing. Totally a possibility. But it's hard to, if you wanted to convert this into a percentage, of of the total percentage of cancer treatments in development or in the clinical trial phase, which ones go through the accelerated approval. I guess it's technically possible that the percentage is going down, but that's probably super difficult to gather good data on that, since treatments are abandoned all the time. Pretty much the majority of treatments for just about any disease are abandoned all the time. Cancer most common to use drugs. That's a tricky thing. Probably not. I would imagine it's statins. Or some sort of heart or cardiovascular disease medication. So yeah, top 50 most filled. Well, okay, vitamin D, I don't really... That is like a medical therapy. Oh, a little bit better. I'm assuming this is probably like some sort of like cholesterol or heart medication. Yeah, hypertension. Well, yeah, this is like also like cholesterol or heart medication, Lipitor. Yeah, improve cholesterol levels. Which, yeah, given, you know, leading causes of death in, you know, whatever, Canada, United States, not all that surprising. This one, I think this is like for a hormone, I believe. It looks like a hormone. Yeah, hypothyroidism. Yeah. That makes sense. Essentially, yeah, for people with thyroid issues. And this one's like heartburn. This is also like some sort of cholesterol or like, you know, cardiovascular medication. And that should be a statin. Also, yeah, high cholesterol. I think it's fair to say that at least, you know, a significant portion of like the most prescribed are basically, you know, heart medications or like cardiovascular. I do think it's the nature of the illness. Obviously, I don't know for sure, but I strongly suspect that it's the illness. Let's say if I were a betting person, I would bet a significant amount of money that it's that. Oh, and Kilo, welcome. Thank you so much for passing by. Nice to see you. And also, shout out to you. See if I can do this properly. But yeah, right now we're going over basically accelerated approval by the FDA and issues with accelerated approval. Where, you know, there's the good in terms of like hopefully trying to... Oh, wow. Thank you so much for the gifted sub. Super appreciated. Very kind of you. But yeah, we're going through basically the double-edged sword. Like we have this accelerated approval of the FDA that is trying to like give people access to life-saving medications. But then there are issues where like there might be not good follow-up or like, you know, basically the drugs are shown to be like ineffective. And yet patients are still being given these drugs because there's a lack of follow-up by the companies and or the FDA. Yeah, it's a really tricky situation where, yeah, as for why doctors prescribe drugs after they've been withdrawn, Parikh chalks it up to habit. Doctors get used to prescribing a drug. It takes time to change. Guidelines offered to clinicians by the NCCN can strengthen those habits, not only because clinicians rely on them for treatment plans, but also because this guidance determines federal healthcare reimbursement. Knowing that patients will be reimbursed for specific drugs influences clinicians' choices, Ramachandran says. Oh, and Globus, welcome. Nice to see you. And shout out to you know, the AI expert. We touched upon AI a little bit today. And I'm doing well. Hope you are too. So this is what we covered in terms of like AI. Because there was a paper recently published, essentially, where we're getting to that place of brain recording, or your brain recordings being translated to speech. and maybe our thoughts at some point, you know, are not going to be so private much longer. Or we might have to take active steps to ensure that our thoughts remain private and actually contained in our brain. And so, yeah, there's a lot of ethical challenges and questions to grapple with that I'm sure, yeah, that you're going to be covering on, if not already, you've covered on your own stream. Where was? Yes, here. Well, so it's totally like good news and like potentially really revolutionary when it comes to like this is being developed for multiple reasons. One is like to restore speech to individuals that have either lost it or never had it. And also to allow people to interface with like certain technologies or like to interface with like an artificial limb, etc., etc. And so, there's huge, vast potential there. But then it's like, maybe our thoughts, or we need to start, making sure that our thoughts, where appropriate, stay in our brain. So in an analysis of 36 drugs that were granted accelerated approval between 2016 and 2018, Ramachandran and her colleagues found inconsistencies in how the NCCN's guidelines were updated. If the FDA had converted a drug to full conventional approval on the basis of strong confirmatory trials, the NCCN guidance often reflected that decision, but the recommendation was less likely to be updated after an FDA withdrawal. The guidelines are regularly updated to always reflect the current therapeutic landscape and FDA approval status, NCCN spokesperson said in an email statement to Nature. Only recently have clinicians grown more aware that accelerated approval drugs might rely on murky evidence. That's a result of efforts from advocacy groups such as Doctors for America, Ramachandran says. There was a concern I had with the LK-99, the potential for smaller, maybe it's also, it's a good thing that it looks like the LK-99, as I'm going to cover in a bit, appears to have like fallen flat on its face, at least for now. Whether I'm not qualified to talk about superconducting technology or its development, as in I have no idea how far away, or even if it's a possibility, of ambient temperature superconductivity is actually even realistic. But from what I'm gathering from like the actual experts, actual like physicists and material chemists, like it seems like sort of like a pie in the sky ambition, or like really far away. I don't know about even some of the articles that I read. They were sort of like downplaying its potential revolutionary aspect, or like pretty much saying like it's, even if it's true, it's like overblown. It may not be as transformational as people think. But like, again, who am I to say? I'm not a physicist. So the effects of accelerated approval can spread beyond US borders. Regulatory agencies in low and middle income countries sometimes rely on decisions made by the FDA and European Medicines Agency. And I think this generally holds true, where I think generally speaking, I can only speak obviously from the Canadian experience of like Health Canada typically lags behind either the FDA or the European Medicines Agency, or like both, in terms of like, as sort of highlighted a little bit earlier with that cystic fibrosis treatment, of like, it was found to be life-changing, and it was approved in the United States by the FDA, but there was this delay in Canada, where like Health Canada was, as mentioned, like dragging its feet. Hey, you gotta wait for us to approve it. When cystic fibrosis patients were saying, hey, like the FDA's approved it, give us access to this life-changing therapy. So some lack their own regulatory framework and also follow the FDA's decisions directly under the guidance of the World Health Organization. Particularly in Latin America, what the FDA says dictates a lot of the things that our regulatory authorities do, says Enrique Soto, an oncologist at the National Institute of Medical Sciences and Nutrition in Mexico City. In part owing to long regulatory delays during the COVID-19 pandemic, drugs approved by the FDA and EMA were allowed to be considered for use even without regulatory approval from Mexican authorities, says. I want to say that room temperature is moving on his pie in the sky, but the way AI development has exploded, I definitely hold my tongue. That's fair. Where, you know, already researchers are, you know, harnessing the power of AI to accelerate their research. The AI and researchers harnessing the power of AI, you know, may very well, you know, reduce superconducting pie in the sky to maybe more the realm of reality. I don't know. I also see the potential of, like, it might slow down research if we get to the place of, like, as I mentioned before, like, one of my greatest concerns is, like, AI generated, you know, fraudulent scientific papers or research. You know, we have AI art, we have AI music, whatever, AI pictures or photographs. We're almost, like, we're on the way to AI generated research papers, but like fake AI generated research papers. And so it might get tricky, like, navigate the scientific research landscape. Already, you know, there's issues with, you know, papers being retracted and fraudulent research, or maybe overhyped research when it comes to even just like the LK-99. So, like, what's going to happen when it's like, you know, like a paper looks like it's coming from this journal, but it's like totally fake and just generated by AI. I don't know how to deal with that. So for yeah, I would, that totally is a thing. Like, at least I can say from the Health Canada perspective, the Canadian perspective, like, it seems to rely on other agencies. Every once in a while, Health Canada is ahead of, let's say, the FDA or the European Medicines Agency, but generally speaking, Health Canada just typically lags behind the FDA or the EMA. Yeah, I don't disagree, but I don't necessarily want to get to a place where, you know, ideally it should be built into every single scientific publication that, you know, reproducibility was like part of the process. But as we sort of saw with the LK-99 situation that we're going to cover in a bit, of like, yeah, this preprint was put out there, and yes, the scientific method occurred, and then, like, it looks like it's essentially been exposed as like a nothing burger, as in not really a thing. You know, arguably, yeah, the scientific process worked in that scientists from around the world tried to reproduce it, and they failed. And so, you know, we can move on. But I don't know that I want to get to the place where we have to have that level of scrutiny on every single publication that comes out. Because I think that will very much slow down the scientific research process. For India, which has its own regulatory body, the Central Drugs Standard Control Organization, and others, the position that the FDA takes on a drug can be very influential. The FDA is still seen as the gold standard in terms of regulatory review and approval. They play a huge role in the international space in terms of setting the bar for what sorts of evidence should be accepted. But Soto says nuances of precisely which FDA approval pathway was used or what surrogate endpoints were measured are often lost in the process. The concept of accelerated approval is poorly known outside the United States, Soto says. In an email statement, an FDA spokesperson said the FDA does not regulate drug products intended for markets outside of the United States. However, the agency encourages global regulatory cooperation and harmonization to improve efficiency of drug development and post-marketing safety surveillance. In the case of atezolizumab for triple-negative breast cancer, the CDSCO permitted the drug's use after the FDA granted accelerated approval in March 2019, but did not mirror the FDA's subsequent actions. In a February 2022 commentary, Akadi and his colleagues reported on how this happened for atezolizumab and 9 other accelerated approval drugs that were withdrawn in the United States the previous year. Although manufacturers use the accelerated approvals to promote the medicines in low and middle income countries, they did not withdraw them there when the data failed to support their continued use. Companies should be accountable to patients across the globe, Akadi says. It's a moral responsibility. I'm like, yeah, I think one of the huge challenges, not just isolated here, but just, no corporate accountability, generally speaking, for just about anything, but especially when it comes to, the pharmaceutical landscape. And again, we're dealing with, human patients, and like life or death situations. And not only people in the United States, but people around the world, essentially might just be getting placebo, or what has shown to been like maybe even worse than placebo. Like a drug can make a situation worse. It totally happens. Yeah. GG. Following discussions between the drug maker and the CDSCO in June 2022, atezolizumab remained approved for triple-negative breast cancer. All of our medicines strictly adhere to the regulatory and promotional requirements of all local healthcare authorities, a Genentech spokesperson said in an email to Nature. The CDSCO did not respond to requests for comment. Medical oncologist Vishal Ayawali at Queen's University in Kingston, Canada, who co-authored the commentary with Akadi, says that it's time for international drug regulators to look beyond the FDA and EMA for guidance. Different countries experience different rates of certain cancers, and low and middle income countries should prioritize drugs for those that are most relevant to their populations instead of relying on the FDA as a surrogate, says. But Matthew Herder, a pharmaceutical law researcher at Dalhousie University in Halifax, Canada, says that the FDA remains an international standard because regulators around the world don't have equivalent resources. As a result, the responsibility to protect people with cancer globally needs to be shared, he says. The WHO needs to take more seriously the problems with established systems like the FDA, he says. We need a more honest conversation about harmonizing, right? Where it's, understandable. In, let's say, developing countries, they're relying on the regulatory agencies, like the FDA or the EMA, to devote resources to hopefully assess whether a therapy is safe and effective. And so, it makes total sense. But then there's obviously drawbacks in terms of like not having their own infrastructure in their own country, but they just don't have the resources. That's obviously, not a priority. I'm sure they have like other priorities as much as they would want to invest. Like it totally makes sense to pretty much use it as a cost-saving measure of like, hey, we'll just generally follow the footsteps of the FDA or the EMA. I mean, like I said, Canada, a developed country, although some people might disagree. I think it's fair to say Canada's a developed country. And Health Canada, in my opinion, and I think its track record holds true, that it typically relies, or at least it looks at the FDA and what the EMA is doing before, it does its own thing. The CDCSO is essentially the equivalent to the FDA in India. For India, which has its own regulatory body, the Central Drug Standard Control Organization, the CDSCO. Where it's like, even though there's been lots of development in India, I think it's fair to say that the infrastructure that the FDA has as an institution is like way ahead, almost certainly, of what the equivalent in India is. And so, it makes sense that it's just going to follow what the FDA does or the EMA does. It's around to replicate totally. And, maybe we should get to a place of like, just like, the WHO exists, the World Health Organization exists. And so it's like, it is a little bit strange, or I can see it as strange. And I can make the argument of like, why does each individual country, need to approve it for their, citizen population? You can certainly, maybe expand the WHO such that, it's pretty much outsourced to them. And, every country has a stake in it, and maybe every country or, countries in appropriate positions can, contribute, providing that infrastructure or funding for that infrastructure. And just like, you're not looking for each country's approval, but it's just, World Health Organization approval. And, hopefully, well, I don't think there's any real reason to think that like, if it can be done by the FDA, that it can't be done by the World Health Organization, or it can't be expanded such that the World Health Organization can do it. Yeah, exactly. Like, obviously there are potentially unique, physiological differences to take into account when it comes to certain drugs, but it's not isolated to country, or it's not by country. Reforms are possible, at least in the United States. In late 2022, the U.S. government enacted the Food and Drug Omnibus Reform Act, or known as FDORA, interesting acronym, which aims to make the accelerated approval process more transparent and gives the FDA greater authority to ensure that drug makers complete confirmatory studies. And that seems to be one of the major challenges of actually holding these drug makers, these pharmaceutical companies, accountable, or ensuring that they're actually doing follow-up. Of like, hey, if we're going to have the accelerated approval, you got to make sure that you're actually like meeting the deadlines of like, hey, we're waiting for the data, the follow-up data. The FDA now requires companies to begin a clinical trial to gather the data needed for a conventional approval before they apply for accelerated approval. It has also begun re-evaluating previous accelerated approvals, a process that has led to high profile withdrawals. Other safeguards give the FDA more authority to ensure that companies withdraw drugs when required to do so. FDORA did a number of good things in terms of increasing the FDA's oversight, Ramachandran says, but the long-term benefits hinge on its implementation, he adds, particularly of the FDA's ability to play more of a role in making clear not just to manufacturers, but also to patients and clinicians what the level of evidence is at the time of approval. Parikh says that the accelerated approval program could be strengthened further by gathering more data during preliminary studies. For instance, investigators could track whether the treatment helps people to survive longer than is typically observed with standard clinical treatments. Comparisons of a drug in a clinical study with real-world data are imperfect, Parikh says, but could still help to guide decision-making. And Ramachandran says professional guidelines that more accurately reflect the FDA's decisions could reduce potential harms. It's very low-hanging fruit for the guidelines to explicitly state when a drug has been through the accelerated approval pathway. And so looking at some of their figures, this is looking at that one particular antibody therapy, atezolizumab, for triple-negative breast cancer. So this is like the timeline. So atezolizumab, an immunotherapy drug approved for use for several cancers, received accelerated approval as a first-line therapy for triple-negative breast cancer and a second-line or later therapy for metastatic bladder cancer. Scores of people were prescribed the drug for these conditions, even after clinical trial data failed to confirm a benefit. So the timeline, color-coded, orange is after accelerated approval, after negative results reported, and after drug withdrawn. So yeah, so it seems like you have like a lag of like a few years, basically, where it received accelerated approval in essentially 2015, 2016, and then you got negative results towards like basically in the middle of 2017. And then it was only withdrawn like pretty much 2-3 years later. And it couldn't be held up, as do I. We are not anti-antibody here. We are pro-body in this space. Realize what the graph's saying. Negative. So that's a fair question. Negative results or like null? Well, I think probably more in the null category. Because let's just, they're generally used interchangeably, but there is sometimes a little bit of a distinction. Like I said, a therapy can make a condition or disease worse. But I think it's just fair to say that in this situation, it basically didn't prove, it didn't beat out placebo in this case. And so I think that's more or less what was found. Negative results reported. So you can see even after the negative results were reported, some people were still getting prescriptions. And then even after withdrawal, there were about, this looks like maybe 3-4% per quarter. But yeah, basically, some people were still being prescribed this drug after it was supposed to be withdrawn from the market, after it was shown to basically not be beneficial to these cancer patients. And so, like, again, companies or the drug makers really aren't being held accountable. The question was like negative for treatment, or yeah, that's fair. So negative for treatment, as in basically, it's not beneficial for these cancer patients. But that is a totally fair question. A spokesperson for the NCCN said that details of the evidence backing the use of a drug are not in the guidelines, but are included in other NCCN resources for clinicians. Spreading that message internationally could also help regulatory authorities in low and middle income countries to weigh up the pros and cons of accelerated approval drugs when making decisions. Further says that the uncertainty that accompanies accelerated approval drugs makes them by far the riskiest drugs available. So that message spreads, he adds, regulators in low and middle income countries relying on the FDA's accelerated approval decisions might do more harm than good. And yeah, sort of as mentioned, going back to even, did I close it again? I did. Oh no, I didn't. Like, yeah, what the FDA is responsible for is like very large. We just went through a little bit, like, I think everyone knows they're in charge of, approving medical therapies and hopefully confirming that they're safe and effective. But then, it's food and drug. So it's like food and, also supplements. I covered this in the beginning of the stream where, again, supplements, at least in this study. But I think this expands beyond just what was studied here, or the supplement study here. Just like, yeah, the supplement industry, the consumer supplement industry is like very poorly regulated. And, I just don't think the resources are there for the FDA to like ensure that, consumer supplements are essentially, not only doing what they're supposed to do and that they're safe and effective, but like what's actually on the label is what is actually inside the bottle. Because again, literally in this study, what was on the label when they go in, like literally it contained nothing of what it was supposed to contain. Like literally 0% of like, hey, basically like, oh, this bottle says vitamin C. There's literally no vitamin C inside. Yeah, it is literally 0%. That is what they highlight. Or like at most for some of them, it's like, literally trace amounts. Where 23 of 57 products, 40% did not contain a detectable amount of the labeled ingredient. Like, you're on verging of half. Of like literally you might just literally be throwing money down the toilet. And in fact, it might even be better for you to just throw your money down the toilet, flush it down the toilet, because some of these supplements contain prohibited substances. Oh wow! Thank you so much, Discount Seth Rogen. Super appreciated and generous of you. Yeah, can't thank you enough. I'm always grateful for your support. Yeah, it is just a scam. Where we're really gambling with people's lives. And I don't blame the FDA for, you know, basically poorly regulating this industry, because, you know, as we just went through, you know, they're dropping the ball here. You know, I think they're doing their best, but I just really think they just don't have the staff and resources to, you know, do what they want to do. And it would probably require just like massive FDA expansion at multiple levels. And School of Rock is a fantastic movie. So before getting onto the LK-99 stuff, although I don't have much to cover there, I did want to cover, you know, even though I cover science and research, I also cover some of the, you know, not so nice side of science, or let's say, you know, science institutions and the infrastructure around science. I definitely try to cover what I would say is, you know, poor research practices and poor university practices. I covered the resignation, you know, the voluntary resignation of the president of Stanford as a result of their research being shown to essentially be, you know, poor quality or maybe outright fraudulent. But, you know, in that situation, it was, you know, Stanford investigating Stanford, as a result of an internal investigation. You know, yeah, they found that the president of Stanford basically, you know, did some bad research, but no real penalty, in my opinion, was given to them. They just voluntarily resigned from their president position, but they still are going to run their lab. But they claim that they're going to make changes. And, you know, this article here, I think maybe speaks to some of the changes that should make in academia, and not just science academia, but maybe academia at large, to hopefully maybe start reforming it to make it better. Because I think tenure is a problem. And I generally lean towards tenure basically not being a thing. I know that there are strong arguments to make for tenure, and I think some of them are valid, but overall I think it does more harm than good. But I'm open to being swayed in the other direction. I think, well, yeah, I think funding will allow, let's say, the FDA to, you know, hopefully hire qualified people. But even then, I'm not even sure there's enough qualified people to even work at the FDA, to be able to actually do what it's supposed to do efficiently. I'm not entirely sure. It may just be an issue of, like, just not enough qualified people. Totally possible. So, is it time for tenure to evolve? After a spate of high-profile tenure denials, U.S. academics are rethinking how this beleaguered academic process can be made more fair. Talu Adamosu didn't think he had reason to worry when he went up for tenure at the University of Virginia in Charlottesville in 2018. His department had been excited to hire him as an assistant professor in 2013, and all had gone well in the third-year review of its progress. Over the next few years, the engineering school that oversaw his department changed its tenure policies. When Adamosu's time came, his application was lauded by his department, but rejected by the school. He was told that part of the problem was that he hadn't published any single author books, the first he'd heard of the requirement. And one of the reasons why I'm against tenure, multiple reasons, but one of them is like this issue of publishing, where, going back to this article that I covered, I think it was last week or the week before, of like, yeah, hopefully we get to a place of either changing how we publish academic journals, or maybe just fully replacing academic journals. Either way, I think some change needs to happen. But as highlighted in this article, and highlighted when I covered it, of like, yeah, this system is in place, and it's like entrenched, it's locked in, and there's virtually no incentive to change. Where, basically, if a researcher, an early career researcher, wants to gain tenure, well, then they need to publish. And they generally need to, publish either like as much as possible, or in, prestigious journals, or both. The ideal situation is, you publish in prestigious journals at high frequency. And so, there's an incentive for these prestigious journals to exist, and there's this incentive if your career depends on it, to publish as much as possible, especially if the decision on whether to grant you tenure is essentially based off of your publication record. Well, then, yeah, you basically want to have high productivity, and ideally publish in high impact or prestigious journals. And then, maybe no surprise, this maybe leads to kind of, I would say, like shady research practices, or like, you might not be incentivized to do the highest quality research, and just, do research that will get published, and just, that will just pass the bar, or, might get past peer review, in a prestigious journal. And so if you have tenure there as like, the bait, I think that contributes pretty much keeping this system entrenched. It's not the only reason, I think, is tenure is part of that. Where again, researchers, early career researchers working at university, like they're generally looking for tenure, or many of them want tenure. Well, that tenure decision, as highlighted in the article, some sort of publication record. And as they sort of say here, they propped up this like arbitrary metric. Not only just publication, but like single author books. I would say it's pretty silly. When Adumosu appealed, the faculty grievance committee raised concerns about racial bias in the engineering school. Adumosu is black. The committee also noted that he should have been held to the tenure criteria that were in place when he was hired, not the revised regulations. Adumosu obtained a second tenure review, but the verdict remained the same. In a 2020 article on the Inside Higher Ed website, the university denied that any bias or procedural errors had contributed to Adumosu's tenure denial. And when asked for a response, the university told Nature it had nothing further to add. But by then, Adumosu wasn't interested in working at the university anymore. This month, he started a position at Morgan State University, a historically black institution in Baltimore, Maryland, and he made sure that tenure was part of the offer before he accepted it. In North America, tenure protects the freedom of academics to pursue the studies of their choice. Right, and I think this is one of the strongest arguments in favor of tenure, that like I can totally see, that, I think academic freedom is a good thing, and I would want to maintain academic freedom. And maybe tenure is the only way to do that. I don't think it is. I hope it's not. But like, yeah, like I think it is fair to say that, it is a strong argument, like for the sake of academic freedom, and basically your career not being on the line if you happen to do research that may be not politically convenient, or just may look optically not good, then like, yeah, you should be free to do that. But yeah, I think the cost is a little bit too high in my opinion, in terms of like, yeah, sort of how academic publishing is done now, not to mention tenure pretty much protecting, I would say, bad actors, or bad actors that have been exposed. I have sort of seen somewhat analogous to the Catholic Church, so like, moving priests around that have been shown to basically abuse children. There's sometimes something similar to that occurs at universities, or at academic institutions. I have totally seen that, where it's like, yeah, basically A faculty member with tenure has been essentially exposed to basically be at the very least shady or explicitly bad actor, and like they're kind of like forced into retirement, but like no real penalty, or like they're just kind of like shuffled around. And they are the outlier, but there are bad scientists. There are arguably villain scientists, super minority, but they do exist. And I definitely don't want them to have tenure. So, yeah, academic freedom. It typically comes with the promotion from assistant professor to associate professor after a probationary period and extensive review by peers at the department, school, and university levels. It also includes the promise that a faculty member cannot be dismissed except in extraordinary circumstances, such as dereliction of duty or violating codes of conduct. Although universities can also let tenured professors go if they discontinue an academic program or find themselves in dire financial straits. The tenure system is designed to make sure that if somebody is let go, it's for reasons that aren't about them asking questions or delving into areas that are controversial. Because I think, yeah, on paper, that sounds like a good thing. Says Todd Benson, Executive Director of the Harvard University Collaborative on Academic Careers in Higher Education in Cambridge, Massachusetts. According to a survey done in 2020 by the American Association of University Professors in Washington, D.C., 87% of U.S. institutions that offer degree-level courses have a tenure system, but Automosu's ordeal demonstrates the power that tenure committees hold, and how the process can derail careers when committees at different levels of the institution disagree, and when criteria change or are opaque. Although tenure denials are relatively rare, a spate of high-profile anecdotes has scholars discussing what tenure means and how they can unravel long-standing biases that keep professors from underrepresented groups from making the grade. The tenure system has also come under attack in the conservative-leaning legislatures of several U.S. states, making academics feel that they must defend it as crucial to academic freedom and education. Kind of risk that non-tenured people might not feel safe to enter. Yeah, and that's why I do think it's a strong argument of like, yeah, academics should have the freedom to investigate controversial topics or ask controversial questions, and have the freedom to investigate those questions. That's why I do think that's an argument in favor of tenure, but I just think, yeah, the downsides are just way too much. I totally enjoy, I have a whole science meme section in my Discord. Thank you for the link, super appreciate it. I obviously can't copy and paste properly. Maybe let's zoomed in. 0. That is, well, I guess to translate, yeah, magnesium is Mg on the periodic table. I appreciate a good science, and that is good. I usually there's not many that are fresh for me. Where was I? Yeah, the tenure under attack, blah, blah, blah. Yeah, so the North American tenure system has sometimes struggled to keep up with the goals of modern academia, but it is changing. Some universities and schools are altering their tenure criteria. Others are seeking to help faculty members to meet the criteria already in place. So, and that's another issue that appears to be occurring with, let's say, tenure, where basically the bar is being perpetually raised, and I think that even holds true when it comes to like just graduating with like a PhD, of like yeah, there's just like higher and higher expectations placed upon you. And like, if you want tenure, I think if you want tenure today, that is, the requirements to meet that are way higher than, let's say, to achieve tenure like 20, 30, 40 years ago. And I think even today, to graduate with a PhD today, I think the expectations are much higher than if you need to graduate with a PhD, 20, 30, 40 years ago. Like, generally speaking now, at least of the institutions that I sort of know of, and, whatever friends and colleagues that I interface with, there's a little bit of it's generally understood that you need, in order to graduate and, defend your PhD, need around, 2-3 publications. And that is like a pretty high bar. Where, let's see if I can find it. One second. Yeah, so there was this article. This is an old article that's highlighted, 9 years old. But like, yeah, this Nobel winner declares boycott of top journals, and he's singling, Nature, Cell, and Science, and these are all journals that I literally cover, because those are like the prestigious ones. But as he says, leading academic journals are distorting the scientific process and represent a tyranny that must be broken, according to a Nobel Prize winner who has declared a boycott on the publications. Won the Nobel Prize in Physiology and Medicine. And that he's saying, like, yeah, he's no longer going to send the papers to the top tier journals, Nature, Cell, and Science. Because, yeah, pressure to publish in luxury journals encourage researchers to cut corners and pursue trendy fields of science instead of doing more important work. The problem was exacerbated, he said, by editors who were not active scientists, but professionals who favored studies that were likely to make a splash. Yeah, I totally 100% agree. And it is a W for sure. But, thankfully, this person now has the luxury to do that. Because it's like, well, now that you've won the Nobel Prize, like, who is going to question, like, you, right? As opposed to if you're like an early career researcher, or you're just trying to like get your career off the ground, then it's like, yeah, you almost have like no choice but to publish, not necessarily publish in Nature, Cell, and Science, but to like publish something, in something as high impact as possible. Definitely not every field or discipline, especially some niche ones, have high chances of getting in Nature, Cell, and Science. And so now as he's sort of highlighting where, pretty much it's publications that matter, well, now it's just sort of an unspoken or like implicit rule. Some PhD programs have it built in that it's a requirement that you publish, X amount. But I think most of them just have like an unspoken rule that you just got to publish if you want to, get your PhD and defend. And so like that, the same thing holds true. Like if you want to get tenure, well then like, yeah, you got to publish as much as possible, and ideally in as prestigious journals as possible. Pretty much just like the ones highlighted here, Nature, Cell, and Science. And this is not to say that these are like bad journals. They generally do publish really cool, generally speaking, high quality research, research that I just covered, of like this semantic reconstruction. Yeah, this one. This is published in Nature. It's a really cool study, super cool. And that has lots of potential positive and negative implications. But at the same time, I think there's a problem, huge problem, with upholding these journals and having them as whatever. Your research only matters, or as was said by the Nobel laureate, like it's only going to make a splash if it's published in these particular journals. You're also risking your reputation by coming out. Yeah, totally. Although generally speaking, most Nobel Prize winners, it's very often, like almost exclusively, given like way after the fact, as in like 20, 30 years later. So typically I think they're close to retirement. Or like very often they have like long since retired. Pretty sure I have very little doubt that this person's pretty old. Oh yeah, age 74. At age 74 today, this is 9 years old. So they were 65 when they were given the Nobel Prize. So, they could have retired if they needed to. But I agree with you. It totally does take courage to come out and say that. And I'm glad that they did, because I don't think this is like recognized and spoken enough about. Because I think it's a huge, huge problem. And contributes to like the current academic publishing system that we have, that I have major problems with. And you're not wrong, they probably would counter the boycott. I mean, already like publishers like Nature, Science, and Cell, like they're doing everything they can to keep this system in place, because as highlighted, they're the ones making all the profits, like the huge profit margins, 40% or more profit margins. I think that was like the number. Yep. Real corporate profit margins exceeding 40%. So it's like, it can be like as high as like 60-75% profit margins. Pretty much like, I think, unheard of in any other industry. So, the North American tenure system has sometimes struggled to keep up with the goals of a modern academia, but it is changing. Some universities and schools are altering their tenure criteria. Others are seeking to help faculty members to meet the criteria already in place. There are campuses that are making those incremental shifts that are really impactful, says Chavella Pittman, a sociologist at Dominican University in River Forest, Illinois, and a consultant on faculty development. Those systemic shortfalls. Modern North American tenure sprang from controversies about academic freedom. In one high-profile case in 1896 at Stanford University in California, economist Edward Ross came under fire for making public political remarks that the founding Stanford family disagreed with. He and several other Stanford professors eventually resigned, and in 1915, a group of academics founded the AAUP to safeguard academic freedom through the tenure mechanism. The AAUP's 1940 Statement of Principles on Academic Freedom and Tenure remains widely cited in faculty handbooks. Tenure is also a perk that compensates scientists and engineers for getting lower salaries than they might command in industry. Which is like, yeah, I can understand that argument as well, where it's like, yeah, you might not be getting the same salary as someone working in industry, but you have like pretty rock solid job security. Not 100%, but pretty darn close. Like, unless you do something pretty egregious. And yeah, 40% markup is nice. and 40% markup or more. 60%, 75%. And it's not even just markup, it's like profit margins as well. Tenure allows scientists to be bold in their research, says engineer Wal Yeho, provost of Worcester Polytechnic Institute in Massachusetts. It made him comfortable with risking a mid-career switch from working on aerospace materials to investigating biomaterials. I think that the tenure system is one of the strongest things about the American education system, says Soboyeho, who was raised in Nigeria and trained in the United Kingdom. But much has changed since the AAUP was founded. Academics today are less likely to simply want to pontificate from ivory towers. Writing a paper that's cited by 4 or 5 people is important, says Malcolm Hill, dean of the faculty at Bates College in Lewiston, Maine. But with climate change, poverty, racism, our faculty are coming in and saying, I want my scholarship to also have relevance to real-world problems. The process of getting tenure has changed too. 1940 document called only for a probationary period. Now the tenure system also involves an onerous review process in which academics need to submit detailed documentation of their value. The criteria frequently come down to contributions in research, teaching, and service. The last 2 factors often don't count nearly as much as the first. Which is like, yeah, pretty much your productivity in research, and again, that metric of publications is what is held up. In addition, tenure criteria can be unclear or open to interpretation, and there are often unwritten requirements that faculty members become aware of only through word of mouth. Plus, tenure committees frequently focus on the factors that are easiest to measure, such as journal impact factors and student course evaluations, rather than looking deeper into the applicant's contributions. And pretty much, yeah, more or less in the same vein of what I was talking about, of like there's sort of like these unwritten rules or guidelines for tenure, just as there are unwritten rules and guidelines for, you know, getting your PhD or defending your PhD. Where it's like, yeah, what's said on paper, not the actual criteria that they uphold. And people such as Adumosu, who come from a marginalized demographic or pursue research that differs from that of the members of the tenure committee, sometimes get short shrift. According to the U.S. National Center for Education Statistics, 79% of full professors are white, only 4% are black, and 4% are Hispanic. In comparison, about 60% of the U.S. population is non-Hispanic white, 14% is black, and 19% is Hispanic. Just like every other institution or anything that is influenced by people, bias is baked in, says Pittman. Problems can also occur with the tenure system at the tail end of a professor's career. If their productivity wanes, says Prabhakar Clement, an engineer at the University of Alabama in Tuscaloosa. I've definitely witnessed people collecting rust and slowing down, and there are cases where we just cannot make them retire, he says. Given all these criticisms, some scholars argue that the tenure system should be scrapped, keep the road less traveled. Clement suggests that universities offer 20-year contracts, after which faculty members would be free to renegotiate or take their services elsewhere. Barring that, he thinks there's room for tenure to evolve and be made more perfect, he says. And intuitively, I don't object to this. And if anything, I think this is a step in the right direction. So the road less traveled. Some individuals and institutions eschew tenure. Columbia University in New York City has been trying to give David Helfand tenure for nearly 4 decades. Each time the astronomer has refused. Tenure does more to suppress academic freedom of those who don't have it, as its protections aren't available to the bulk of academics today, who hold adjunct or non-tenure track positions, he explains. It just seemed like a system that was in desperate need of reform and that I didn't want to participate in. So when he came out for tenure at Columbia, he said no thanks. It took 2 years of negotiation to convince the university's provost to put him on 5-year contracts. As each term expires, Helfand writes up his accomplishments and intentions exercise that he finds useful. His process is similar to what happens at Olin College of Engineering in Needham, Massachusetts, which was founded in 1997 with a no tenure policy as one of its precepts. However, the college still had to come up with a way to evaluate faculty and promote their development, says Emeritus Associate Provost Vincent Mano. Each year, the Olin system assesses professors on activities that support three key purposes: development of students, support of the institution, and impact beyond Olin. Biases and other problems that pop up in tenure reviews can happen in Olin's reviews too, but more than half of the current faculty members have been at Olin for more than a decade, and several are approaching the 20-year mark, says Mano, suggesting that professors can thrive without tenure. As for Helfand, he's thrived too, but in July 2022, the provost refused to give him a new limited-term contract, so he has de facto tenure after all. So basically, you know, after decades of rejecting tenure, this researcher just never kind of like got it by default. So tweaking tenure practices. It's that kind of incremental evolutionary change that Bates College enacted in 2021 when it broadened tenure criteria beyond requiring peer-reviewed journal papers to also include contributions such as work with professional associations, efforts to remove barriers of oppression in the university, and community-based research. Although it's too early to quantify the results of these changes, Hill hopes it will signal to faculty members new and old that Bates values a variety of scholarship. Worcester Polytechnic also broadened its tenure system in 2021 to offer tenure to professors who focus more on teaching than research, who weren't eligible before. Already, the institution is seeing benefits, says Soboyeho, including a substantial drop in the attrition rate for teaching-focused faculty members. Universities can also rethink how they evaluate professors for tenure. In the case of teaching, Benson notes that women and people of color are known to score lower than do white men in student evaluations. As such, many institutions have revised or dropped their use of student ratings according to the AAUP. Which, this is very curious. Although not necessarily surprising. Another change institutions can make is to limit the amount of materials required in a tenure application, suggests Deborah J. Cohen, a sociologist at the University of South Carolina, Beaufort. I remember someone telling me that you should save every conference program that you were in and your name tag, she says. It's just too much. Which actually, this is, like, this is not something that I've done for tenure, because I have no intention of ever pursuing that route. But I would totally, like, you know, for each conference that you go to, generally speaking, you know, you get, like, a book of abstracts or some sort of, like, you know, documentation that, you know, you went to the conference. And also you get a name badge, you know, obviously has your name and the institution where you're working out of. And I have totally, you know, you get some sort of lanyard. I have, like, I don't know, 10, 12 lanyards from all the conferences that I've attended. And like, yeah, they're doing it, like, I'm just doing it more or less for the sake of it, which is, like, you know, as kind of like keepsakes. But they're doing it literally to pretty much, you know, prove that they're being productive, that they're attending conferences. Oh yeah, I totally have quite a few lanyards, although most conferences don't invest in high quality lanyards. When I say lanyards, some of them are literally just, like, you know, a fancy shoestring. Some of them do have, like, you know, they're, like, embroidered and have, like, the name of, like, the conference. Other ones, let's say the ones that are, like, run by students or organized by students, you know, they cheap out, and it's, like, just, you know, like a piece of dental floss. And Cohen has witnessed tenure committees consider factors they shouldn't, such as whether someone is a great office mate or if they're happy at the institution. People who don't fit in owing to aspects of their identity or their research focus can get pushed out, says Adamosu. If you have outsized personalities that are driving the process, it can easily lead to monoculture. Researchers at the University of Denver in Colorado say they have a remedy for that in a decision-making protocol that several of its colleges and schools have implemented in the past couple of years. Called deliberative decision-making, It's a two-step process that anyone can learn in a 2-hour online training session. The process grew out of the research of Darren Hicks, a communications professor at the university, and a committee he led. Step 1 is to discuss the criteria for decisions. What would a successful tenure application look like? Simply asking this led committees in the university's Graduate School of Social Work to update and clarify their criteria, says Kate Willink, former vice provost of faculty affairs and a specialist in communication studies. For example, the school has now explicitly listed podcasts and other public-facing scholarship as research contributions, which I'd say that's pretty cool. I can get behind that. Unless it's the Joe Rogan podcast, then I don't think it should count. If anything, that's like a demerit. I think maybe that should be held against you. Then in step 2, the committee considers individual applications, but the system is set up so that no one person can dominate the discussion. The order of speakers is drawn from a hat, and everyone gets the same amount of time to state their opinions, with a timekeeper to keep everyone on track. So it seems like, a more structured kind of like defense or tenure application. Although it's too soon for hard data, Willink and Hicks say they've received positive feedback from committee members who have used deliberative decision-making. Hicks says that women and faculty members of color who participated in committees that implemented the process have told them how much they prefer it and that it makes them more confident in the final results. There are also training programs that faculties... oh wow, Socrates, welcome, and welcome raiders. Thank you so much for the raid, Socrates. Super appreciate it, and shout out to you. I hope you're doing well, and I hope you enjoyed your stream. Let's see. I think I can do it properly. But yeah, I hope you enjoyed your stream, and welcome. I am Corey Campbell. I'm a biochemist. I cover science, research, and news. And right now we're going over this article about tenure and how maybe we should abolish tenure, or at least maybe not abolish but reform it, given what I would say are its clear problems, drawbacks. And also, if I remember correctly, I think you were like on a panel yesterday. I tried to tune in, but I didn't get the chance. I'm probably gonna check it out later. But hopefully the panel went well, which I have no doubt that it did. At the very least, I hope it was productive. But I know that's hit or miss when it comes to panels. I totally have some articles on okay, so second. Well, have some research on TikTok. See if I can find it. That hard to find. I don't think I have that many articles. I only know, let's say, the research when it comes to misinformation on, let's say, social media and TikTok. And no surprise, TikTok is pretty good at spreading misinformation, or it's not the go-to for accurate information. But for social contagion, I know that there is some research out there. I haven't looked at it or rather, I haven't looked at it closely. I've read like a few abstracts and headlines. I haven't done a deep dive, but from what I understand, and from what I can gather from my limited, reading, it doesn't seem to be much of a thing, or maybe like overblown a little bit. But maybe I should clarify by what exactly I mean by social contagion. Like social contagion in terms of like, TikTok actually like spreading ideas, or I know that there was like this phenomenon of like TikTok and its ability to like, induce tics in people, that type of stuff. Oh, and Cernu, welcome. Nice to see you. Hope you're doing well. So okay, that specific claim, I think that's a high bar. I haven't seen any research on that. Uh, but I don't think. Uh, yeah, I don't think I'll reserve judgment, but I'm pretty skeptical of that claim. Yeah, so much about misinformation, very little. Well, you know, Mr. Information got their time in the spotlight. You know, I think there's a decent amount of history focusing too much on Mr. Information. So now is the time for misinformation. So I'll draw upon other research. Because there is research on social media, not TikTok specifically. But I covered this research, I think like last week or a few streams ago. See if I can find it. So, I think the larger question, like, I think if you zoom out, it's like, you know, TikTok in the domain of social media. So, like, how, what power does social media have in, you know, affecting behavior, or your attitudes, opinions, beliefs? And at least in this study here, it didn't seem to pan out. As in, you know, there's this concern that, you know, social media is somehow like influencing politics, and like political behavior and all that stuff. And that did, at least this is not TikTok specific, but like this was like Facebook specifically. And at least when it came to that, it didn't seem to have like much of an effect, or like it wasn't actually affecting attitudes and behavior in an election campaign. Now, obviously, that's, you know, a different question than whether actually TikTok specifically can, you know, either make someone believe that they're trans or non-binary, or influence that one way or the other. But I think this fits under the broader category of social media's ability to, you know, basically influence behavior. And at least for this, didn't seem to pan out. And so I'd be highly skeptical that TikTok has that ability. And until I actually see a study that actually, you know, provides evidence that it can do that, I'm gonna lean towards TikTok not having this social contagion phenomenon. The topic we're on now, well, despite that tangent, the topic we're on now is about tenure. Sorry for the sidetrack. But yeah, this article about tenure, and maybe reforming or changing tenure, or maybe getting rid of it entirely. But at the very least, pointing out some of its flaws, and maybe things that we can do to make it better. And right now, I think one of the good ideas that they're putting forth is like, you know, instead of like, you know, tenure, like lifetime appointment, maybe just like long-term, like decades-long contracts, or like 20-year contracts that can be renewed. I think that's a step in the right direction. So, although it's too soon for hard data, Willink and Hicks says they've received positive feedback from commuters who, yeah, I already read that. Yeah, changing metrics or requirements. Coppola says it's important to support faculty members to meet the criteria already in place. His department has worked to ensure that new faculty members can teach large introductory courses effectively. A senior professor is assigned to handle the logistics and provide the syllabus so that the new professors can focus on their teaching. And the initiative has helped those new professors achieve ratings as good as or better than those of more experienced peers, says Coppola. Professors who assemble tenure packages can consider modern ways to measure their scholarly impact in terms of web and social media metrics, says Heather Coates, a data and metrics librarian at Purdue University, Indianapolis. A bit redundant there. For example, she says they could track when studies are shared online by a professional society or another prominent scholar. Some data back up this practice. Bookmarks and downloads of papers on the reference management software Mendeley. That's what this is right here, Mendeley. Even though I probably don't recommend it anymore, seems to be getting worse over time, and they're moving to basically a cloud-based service, and the desktop version that I have is essentially being phased out. I'm not in favor of. But yeah, Refware management software Mendeley, for instance, are known to reflect future citations of that work. These metrics can also be found on Altmetric from Digital Science and Plumex metrics from Elsevier. Digital Science is operated by the Hold Spring Publishing Group, which has a majority share in Nature Publisher, Springer Nature, blah, blah, blah. But Coates warns these metrics are so new that it's hard to say what a good social media statistic looks like. Is 1,000 pay-per-views good? 20,000? The answer will vary by research area. Use them with caution, Coates says. The evolution of tenure to reflect modern academic life and to value community engagement will ultimately help tenure's ongoing public relations problem, says AAUP Treasurer Chris Sinclair, a mathematician at the University of Oregon in Eugene. The public, he argues, needs to know what faculty members are doing and why tenure protections are important. We as faculty need to get better at being able to communicate that, which is like, yeah. I think academia as a whole has a PR problem and a communication problem. In my experience, and my experience might be limited or unique to me, but in my experience, academics, and I might be included in that, but they're pretty poor communicators, are not the best at conveying their ideas. So, the last topic, and I guess main topic, although pretty short, and the other main topic that's in my stream title, I'll basically, it looks like the superconductor issue is over. So tenure is essentially what university professors get. It's basically the ultimate job security of, like, I wonder how Wikipedia defines it. Yeah. So it's an academic appointment that's indefinite. As in, like, so, once you, generally speaking, I'll only share, let's say, the science sort of route to tenure. Generally speaking. Obviously, it's not going to apply to every single situation. But generally, once, you've graduated with your PhD, or, defended and graduated with your PhD, you will typically, if not, if you want to become a university professor and do your own research, pretty much have to do a postdoc, at least one, if not, multiple, and then you apply to pretty much, become a professor, like either an assistant or associate professor. I believe it's starting off as assistant, or like basically, a research/professor at university, and then, pretty much start your research career. And then, like, for the next few years, typically around like 4 to 5, you're expected to pretty much be productive, and, start your research. And then, once you've kind of like built up your CV, you would apply for tenure, as in, like, pretty much, typically, rather, it's essentially like a lifetime appointment of, like, you are there, and your job's not really going anywhere, and that, you pretty much have ultimate job security. Yeah, it's just, yeah, that makes intuitive sense. But you can be denied tenure, where it's like you might spend like 5 years at an academic institution, and, with every intention of starting your career, and have, large, bold ambitions. And then, you've invested 5 years at the institution, and, you maybe published a lot and done a lot of things. And then, you go and make your case to the university, and they can totally deny you. And that, they touch upon that in the article. And that's one of the reasons why they're arguing for at least changing the tenure track system. But there's an argument to be made that, like, yeah, we should have tenure for the sake of academic freedom. I don't really buy that. I think the 20-year sort of appointment, or some sort of like long-term appointment, I would say maybe 20 years the max. I'd maybe want to start off at like 10 years. But yeah, to essentially cover the last topic. This was published yesterday, so I'd say pretty up to date, but I'm sure there was something published today. I think largely saying the same thing, but this person, who is a physicist, and they were one of, when I covered and read another article covering this situation, they were one of the persons quoted, one of the, the experts quoted. And they're pretty much saying, like, yeah, the LK-99 saga appears to be over, but three-day grace period for memes to pretty much make fun of the situation, which I can totally get behind. I have no doubt that there's going to be a bunch of LK-99 memes for years to come. But hey, you never know. This is just one person in the field and discipline saying this, and they could be wrong. But from everything that I can gather, the LK-99 situation basically appears to be like a nothing burger. As in, like, oh, false alarm, no room temperature superconducting has occurred. But just to go through this article a little bit more in-depthly, physics graduate student Hope Whitelock popped her head out of the lab at the University of Colorado at Boulder on a recent morning to ask a bunch of scientists standing in the hallway for a quick gut check. Someone tell me if something is crazy. It's been a few weeks of craziness for physicists and chemists scrambling to make sense of a grandiose claim that popped up in late July. The purported discovery by a team in South Korea of a material that conducts electricity at normal room temperature and air pressure without losing any energy. Possibility of this long-sought material, called a room temperature superconductor, quickly went viral, fueled by a video showing a lump of the stuff partially levitating as evidence of its extraordinary properties. Now the claim is rapidly deflating under scientific study. Over the last few days, papers from academic labs scattered across the globe have built up evidence that the material, dubbed LK-99, is not a superconductor and is more likely a type of magnet. Hyun-Tak Kim, a co-author of one of the discovery papers and a physicist at William & Mary, countered in an email that other research groups' failure to replicate their results are probably because they lack know-how in developing the sample the same way. Like, that might be true. I'm not qualified to comment on this. But from what I understand, in order to generate, the superconducting property, they first have to, make the material. And it seems like one of the main criticisms is that, like, no one is actually making the material, or basically no one's actually reproducing what was in that, preprint publication. The episode has provided the public with an unusual front-row glimpse at a fundamental part of how science works. Almost as soon as the initial paper appeared online, enthusiasts amplified the excitement among non-experts, explaining the profound implications of LK-99, if LK-99 is the real deal. A revolution for the power grid, more powerful medical imaging technologies, magnetically levitating trains, nothing short of a new era for humanity, and a slam-dunk Nobel Prize to boot. Suddenly, people who had never before heard of a superconductor considered the potential ripple effects of the technology. Careful experiments and abstruse calculations in academic labs were catapulted into mainstream interest. Whitelock says high school friends got in touch with her to ask what she thought. Other groups live-streamed their do-it-yourself attempts to recreate the material. Some onlookers put money on it, predicting whether it would pan out in volatile online betting markets. The frenzy over LK-99 meant that scientific thinking evolved on an almost hourly basis, as new findings and videos of varying quality were shared, often via social media. Philip W. Phillips, a little bit redundant, a condensed matter theoretical physicist at the University of Illinois at Urbana-Champaign, was intrigued by the finding late last week. despite his doubts and questions about the initial papers. You don't want to miss out on what could be the next big thing. That really drives physicists. It drives us all, Phillips said on Friday. By Tuesday night, though, the case was closed for him, based on a series of papers that came online in the last day making a convincing case that LK-99 is not a superconductor. One more nail in the coffin, Phillips wrote in an email, forwarding yet another paper that adds to the pile of evidence. So your headline is quite simple. The phenomenon of superconductivity, materials that transmit electricity without resistance, was discovered more than a century ago. The catch has been that the superconductors made so far must operate at extreme conditions, ultra-cold temperatures or crushing pressures, that are impractical for incorporating into most human technology. A superconductor that could work in a typical human environment that wasn't super toxic or outrageously expensive could be transformative. On July 22nd, South Korean scientists posted 2 papers to the popular physics site archive, or basically physics archive, describing a superconductor that they claimed works at standard temperatures and pressures, made of a modified version of a substance called lead apatite. They provided a recipe for a material that could be created from cheap, abundant ingredients and a video of a partially floating rock. Scientists are a skeptical lot. It's a part of the job requirement. There's no known reason that a room temperature superconductor couldn't exist, but decades of experiments have failed to identify one. The field is littered with claims that haven't panned out for various reasons, and many physicists assume the new papers would be the latest addition to a long list of apocryphal claims. But scientists are also, by their nature, open-minded and comfortable dwelling at the edge of the unknown. Part of the reason they plug away in labs for decades is because they hope to discover or understand things that haven't yet been uncovered. A legitimate discovery of a room temperature superconductor would be huge. Phillips said it would carry echoes of the meeting of the American Physical Society in March 1987, the so-called Woodstock of physics. Maybe a little bit of an exaggeration. That meeting came a year after a high-temperature superconductor had been identified and then quickly replicated by labs across the world, leading to a Nobel Prize by the fall. High temperature is a bit overstated in this case, as the initial material only worked at minus 400 degrees Fahrenheit, far colder than room temperature. But the announcement kicked off the discovery of a new class of superconductors that scientists are still trying to understand. Even the possibility that something similarly significant was on the horizon was enough to make many serious scientists drop what they were working on to give it a rigorous test. Baking a batch of LK-99. One such experiment has been underway in the labs of physicists Daniel Dessau and Gang Ao and chemist Joseph Mitchell at the University of Colorado at Boulder. That's where Whitelock recently called her colleagues to come look at the end result of baking chemicals together for 2 days at 1700 degrees Fahrenheit. The experiment had once again resulted in a mess of materials and byproducts with various properties, something many groups have observed when following the recipe provided by the South Korean scientist. But when Whitelock broke open the vacuum-sealed tube where she tried to bake LK-99, she observed something she hadn't gotten on past runs. A few intriguing fragments of material that were exhibiting interesting magnetic properties. And this seems to be one of the major sort of hurdles, at least to my understanding. Again, I'm not a physicist, but this seems to be one of the major hurdles of, like, actually truly replicating what, they said that they're making. This is one of the challenges of reproducibility. And that's also one of, I guess the outs or the explanations that the original publishers can provide of, like, hey, you're not actually making what we're making. And until you actually do, you're not actually reproducing what we've done. There are a number of tests to identify a superconductor, including one called the Meissner effect, in which a material expels its magnetic field as it transitions to become a superconductor. This could lead to the half-levitating rock effect seen in the viral video purporting to show LK-99, but so could other magnetic properties. You can kind of see that there are some flakes on here that they're tipped up. Whitelock said, showing through a microscope, that what tiny flecks of the material look like on top of a magnet. He was quick to point out that this was not evidence of superconductivity. A short walk away, graduate student Andrew Omis has been retooling the recipe laid out in the original papers by following his own intuitions as a chemist. See if they can get a more pure form of LK-99. During a visit to the lab this week, his latest batch was in the oven, a glowing liquid in a crucible made of quartz, heated to a sweltering 1800 degrees Fahrenheit. So far, though, all the samples produced in Dessau's and Mitchell's labs have failed basic tests of superconductivity. Dessau said he is keeping his mind open that there may yet be some material of interest in the mixture created by the recipe. Plus, he said a room temperature superconductor would have incredible implications, so I think it's worthwhile getting excited about. An ongoing quest for superconductors. LK-99 has been a scientific roller coaster, and most experts are glad the public came along for the ride. Other physicists contend that the original authors should have done more careful work. Again, if it holds true that, they essentially published, bad research, then they should have done their due diligence. But as mentioned before, our current publishing system does not incentivize or reward, doing your due diligence. It's pretty much like whatever can pass the bar, get to publication. The paper would have benefited from peer review before making such extravagant claims, but the burst of interest and increased awareness that scientists are trying to make superconductors is probably a good thing, they argue. The part of it where it shines a light on the subject and its potential utility, and how it's super fascinating and could eventually lead to a breakthrough technology, that part of it is great, said Mason Barkeshli, a theoretical condensed matter physicist at the University of Maryland. I guess my conclusion on all this is I'm kind of happy to see it. It's the first time in a really long time that we've seen science not be so political. We're all just happy about science, and it's kind of cool, said Christopher H. Hendon, an associate professor in the Department of Chemistry and Biochemistry at the University of Oregon. He co-authored a paper shared on social media Tuesday afternoon that concludes LK-99 would more likely be a magnet rather than an ambient temperature and pressure superconductor. If LK-99 is just a magnet, the whimper of deflating interest will be a potent reminder for the general public that science is constantly evolving. Far from a setback, the quest to create and understand superconductors will march forward. At the end of the day, science fails more often than not, Hendon said. That is totally true, and I think an often overlooked and understandably unknown aspect of science. Just like the majority of what you do is just like not going to work. The vast majority of what you're going to do. Like 90% plus. Adding that this would not be surprising if LK-99 went the way of most experiments. That's how science is. Which, yeah, totally true. And confirm. Saving this later. I think that's pretty much that is actually everything that I want to cover. All the content that I had outlined. I definitely have more content to cover. But I think I just want to cover the main ones. So with that, see if I can find someone to raid. Oh, Science is streaming. I think I'm gonna raid into them. Great question. As always, Doffy. I think, the environmental implications are huge in terms of, from what I understand. This is just going by what I read about the potential benefits, if in fact, this was true, even though it turns out it's likely not true. But with this type of superconductor technology, it seems like it might have, really major implications for high-speed rail and things like that. And I think maybe for automobiles, but I'm less certain about that. And so I see it as, there's great potential for pretty much the development of much greater high-speed rail that is way more environmentally friendly if done properly. And outside of that, I'm not sure what the other environmental implications. I'm sure there's like a whole host of others. I'm just like not qualified to like really comment on them. I guess, well, yeah, for electricity, I don't know for sure, but I assume it's also just like way more efficient when it comes to like, you know, electricity. And so if it just like makes basically, you know, power delivery way more efficient, then like, yeah, presumably, it's just like me literally thinking out loud, but presumably, you know, we don't need to produce as much electricity and power, since like, you know, we've just made it dramatically way more efficient, and so presumably that would reduce significantly the environmental impact. And that's all with the caveat of like assuming what I'm saying is true, and I don't know for sure that is actually true. But I have very little doubt that it would be pretty much be a good for the environment if this in fact was true, because at least based off of the way it's described, it's potentially transformative in a positive way to like very many aspects of technology. So we're gonna set up the raid. Science. And yeah, I plan to be back tomorrow. Even though I got through all the content that I wanted to get through today, I still have way more content that I want to cover. And so I'm gonna cover that tomorrow. Or at least I plan to be back tomorrow. That's what I put in the schedule in the Discord. And again, for anyone that wants to join the Discord and recommend topics, post science memes, you're more than welcome. And also to see my streaming schedule. And yeah, I want to thank everyone that passed by. That's pretty true. Always a pleasure. Doffy, Surnu, Bob Marley, Kilo the Giant, Socrates. Thank you for the raid and for passing by. Super appreciated. And also shout out to them. That's not. And if you're not following science, you should be, because they are also a science streamer. They are molecular biologists, and they also cover science and news. And they also do arts and crafts streams and a whole bunch of other fun stuff. But yeah, I plan to be back tomorrow. Have way more content to get through, and I'm sure I'm forgetting a bunch of people, which I apologize. And yeah, Kilo the Giant, thank you so much for passing by, and also for the gifted sub, and thank you Discount Seth Rogen for the sub. And yeah, I should be back tomorrow, pretty much roughly around the same time. I'm gonna try for a little bit earlier, but no guarantees. At the very least, it should be around roughly the same time. So yeah, we're gonna raid into science. And yeah, can't thank everyone enough. Super appreciate it, super grateful. And yeah, give science a follow if you're not already following them. And until next time, take care, be well, be kind.